We're making our very first game to learn Unreal Engine. In this series, we've done some art, we've done some level blockouts, we've done some programming. So what is still missing at this point? In this second section of videos, what we're going to be focusing on is a lot of character stuff. That being AI, that being replacing our own character with a custom-made character with our own animations, and setting all of that up in a way where we can fairly easily expand into making more AI enemies, or even making more different playable characters if we would want to in the future. Today we're going to get started with making the basics of an AI. For that, I'm going to go back into our default third-person map, and we're just going to show you how everything works in here. There's two main ways to make AI in Unreal Engine. You might just want to make something simple in a blueprint that just says, hey, do this, then do this, then do this. A normal bit of blueprint code like any other. But Unreal has both behavior trees and state trees. They behave somewhat similarly. State trees are a little bit newer and pretty much take what behavior trees can do, which is just making decisions and then doing something, and kind of builds upon it to allow you to layer multiple different actions on top of each other and more easily create loops of behavior. If you're a little bit confused as to what that means, we're going to dive into it and actually experiment with, well, how to set these things up in a moment. So state trees is what we're going to be using. I will go into my tutorial folder here. I'll zoom out a little bit and I will make a new folder real quick and I'll call that AI. We're going to put all of our enemies in here. I'll just make a folder for enemy 1. And in there, I'm going to make a blueprint class. I'm just going to make it a character for now, and we'll call this BP base enemy. And that is because all the enemies that we're going to be making in the future are going to inherit. They're going to be child blueprints of this base enemy. That means that this base enemy isn't going to have any particular interesting code. All that it's going to do is it's going to create a couple of variables, add some components that we need, and then everything else that is a child blueprint of this is going to do the actual stuff that we want it to do. So, opening that up, we're going to add a component, and we'll add a state tree component. There's both a state tree and a state tree AI component. You might think, oh, we're making an AI, so I'm going to use a state tree AI. The difference is that the state tree component itself is supposed to run on a actor. So that is either just a normal actor, a pawn, a character, anything that is actually existent within the world. A state tree AI is a specific type of component that assumes that it's going to be running on an AI controller. So the same way we have a player controller, which we've explored a little bit in the past, AI controllers are similar things that just give artificial intelligence inputs and instructions as to what to do. Some types of AI behavior you might want to run on the controller and just tell the pawn, hey, you go do this, this, and this, no matter which type of pawn it is possessing. I personally much prefer oftentimes to use the normal state tree component and actually give it to the individual actors so that the actors themselves do the stuff they're supposed to do. We're going to be adding a normal state tree component to this thing. We can just keep the name as state tree, or give it a name as you like to. And then in the details panel over here, you can see that we can give it a state tree that is going to be running. Let's move the base enemy just from enemy 1 folder into the AI folder, just so that we have everything set up properly. And then we make a child blueprint of it, and we'll call this BP enemy 1. Enemy 1 goes into its folder, and now that is a child of our base enemy. I don't know if I've showed this before, but these base classes, which are blueprints that you don't actually want to put into the world and only really exist to make child blueprints of that share the same set of variables or components or functions or whatever, you can actually mark these in a way that you can't put them into the world, even by accident. So if you want to do that, you come up into the, in this case, BP base enemy. We go into the class settings. And here in advanced, we can generate this as an abstract class. And an abstract class just means that it is a class, a blueprint, that is meant to be inherited from, but not meant to actually be instanced by itself. You'll see if I try to drag this into the world, It doesn't do anything because it is abstract, while the child blueprint I just made off of it is entirely able to exist within the world, no problem. That said, let's open up that child blueprint real quick and give it a mesh just as a placeholder. We'll just use the many simple. We'll make our own mesh for this sooner or later, but for now, this will do. And it is time to make our first state tree. So we can just right click, we can go through into artificial intelligence, and here you can make a behavior tree or a blackboard. These two things work with the behavior tree system. Again, an entirely fine way to make AI as well. I like state trees because by default it behaves very similarly, but it is easier to expand on, and also, in my opinion, easier to gain a decent understanding of. So we'll make a state tree, and here we can see the different schemas that exist. These are the state tree types. So by default, we only have the normal one and the AI one. And we also have one for a camera director, which works with the gameplay camera system. You can change which camera is active based on the state tree. It's actually kind of neat. By and large, this will be enough. Expanding this requires some C++ input and doesn't really gain you all that much aside from maybe being able to add a couple of extra default variables to a state schema. But it is technically possible to expand on this if you need to. Since we made a normal state tree component before, we're going to use the normal state tree component schema. And we'll call this st for state tree, example enemy. And let's open that up and see what state trees look like. We'll circle back to the debugger later, and this is the interface that we're going to be working with. So a state tree is kind of like a whole bunch of little blueprints that get run one after another and can transition from one to another. So we always enter the state tree in the root, the topmost one of these, well, states, nodes, whatever you want to call them. Then we can add a child state to it. This root is going to, because its selection behavior is set to try to select its children in order, it's going to go, when it is selected, which is what it will be by default, it's going to try to enter this state. We can set entry conditions as to whether or not it's allowed to enter this specific state, and if it is not, it's going to try to enter the next state. So if we add another child state here, it will first try to enter this one, and if it cannot do that, it will then enter this one instead. Both of these have an arrow with the word root next to it, which is just to say that when whatever this state does finishes up, it's going to go back up to the root, and then the root is going to try to select the children in order, and that way we can create a little bit of a loop of behavior. The wonderful thing is, if it goes from root into state number 1, and while it's doing whatever it's doing in state number 1, changes something in a way where this entry condition then becomes not satisfied anymore, this will finish up, it'll go back to the root, it will try to select its children in order, so it's going to check this one, see, hey, the entry condition is no longer met, and then go on to this one, which will then go back to root, and then it will try to enter this one again, and maybe by that time the entry condition actually has been met again. So it will go through into this one. It also has a bunch of different selection behaviors. It can just select them at random, so it'll go just pick anything that is directly under me and do that. We can try to select it by the highest utility. We can give every single one of the states a utility weight, and these can be based on different types of inputs. So let's say that it is the distance to the player. If the distance to the player is beyond a certain amount, so this one weighs from 0 to 1, for instance, based on how far it is to the player on a scale of 2,000 units. Well, this one will always just have a static weight of 0.5. That means that if we are very close to the player, it will do this one, and if we are very far away from the player, it will do this one. We can introduce a little bit of randomness by that as well, where we do still pick them at random, but we weigh them by their utility score, meaning that while it is random, things with a higher utility score when the state is being picked have a higher likelihood, well, to be picked. Or we can tell it to try to follow the transitions that exist on this state, which is just going to enter it and wait for one of the transitions to actually trigger for it to move on to, well, whatever that transition says. We'll talk a little bit more about transitions in a moment. All that probably sounds like a whole bunch of abstracted mumbo jumbo, which might not land entirely. So now that we've talked about all that and just created a basis, we're going to actually, well, do something with it. We're going to keep it super simple. All that we're going to do is we're going to make a list of points, and it's going to walk from point 1 to point 2 to point 3 back to point 1. So every one of these states can have a number of tasks within them. If we click on this little plus icon, we can add a new task, and by default there aren't that many that exist for the normal state tree schema. We can run an environment query, which we'll talk about maybe sometime in the future. We can run an entirely extra parallel tree while within this state. We can just draw some debug text, and we can do a delay task. That's just going to set a timer with a little bit of randomness potentially and complete the task when that timer runs out. Nothing that's particularly useful, so we need to make our own, for which we can come up here and just make a new task. And it gives you a list of all the tasks that already exist that you can build off of. By default, that's only going to be the state tree task blueprint base. You can also do that just as any blueprint at any different time by coming into the blueprint class making menu here and just look for state tree task. And you will see that we have object state tree node blueprint base, and then we have the state tree task blueprint base. It's the exact same thing, just two different routes to make this same thing. So let's make this and call this STT for state tree task underscore move to target actor. We can open this up, and this creates us a blueprint, which is the behavior that this task is going to exhibit. It has a couple of overridable functions here, a get description. So whatever we put into here is going to show up as a description in our state tree. So let's say moves to targets, just moves to targets. You can, of course, since this is a function, make it include variables or whatever other types of information into this output text. So it actually becomes very descriptive when looking at your state tree. Then we have a state completed, which personally I don't use that often, but there is a small difference between exiting a state and a state being completed. While this code runs, you technically still are within this state, while when the code for exit state runs, well, that runs when you have exited the state. These two effectively always run immediately after each other and are oftentimes pretty much interchangeable. I find myself personally using exit state more often than not. And then every state also has a tick. So what do we need to do? We have an actor that the state tree is running on that needs to move to a goal location. There's a variety of different ways that we can do this. What I'm going to do is I'm going to take in two variables here. We're going to take in the points, and that is going to be a actor type of variable, object reference. And we're going to go over into the details panel and make this into an array. This way we can give in as many different points as we want, and we can pick one of the points from that array. Let's make that exposed by clicking the little eyeball icon. And before we actually move on, I'm going to go back into the state tree and add this task to show you how this looks in the state tree. And you can start understanding a little bit as to how we're putting this stuff together. So going back to the state tree, we'll call this just patrol and add the task to it that we just made, STT move target actor. This takes in a number of points, so we can just make a couple of active variables. Fantastic. What we actually want to do though, is we want to make this a parameter for the entire state tree. That way, what we can do is we can put this enemy a couple of times in the level, and every single one can have its own list of points that it walks between. So let's do that. We can come up here into the parameters for the state tree and just make a new parameter if we wanted to. Or what we can do is we can just click on this little value here and promote to parameter. Then we can choose which set of parameters that we want to add it to. In our case, a global parameter, one that goes for the entire state tree does make the most sense. So we just add it in there, and you can see now we have this parameter existing here. So it's going to take the array that exists within this parameters list and supply it in for our task to work with. Putting any of these enemy 1 type blueprints into the world now, if we scroll down to its state tree, we will be able to see that if we give in the state tree example enemy, it also has that parameter now existing here. So if we enable this, we can start populating this with values. So we can say you want to walk from this actor to this actor, and now this state tree for this specific instance will work between these two actors. If I drag in a different enemy and also give this one the same state tree, you will see that it doesn't share the same parameters. It doesn't have the same goals to walk to. This one can have its very own set of goals to walk to. So that is why we do this with a parameter set. Now we have that list, that array of points that it can walk between, but we need to keep track of which one is the next up that we need to go to. So let's make it also take in a integer, and that will be of type, of course, integer. This won't need to be an array. This can just be a single value. And now we can make our enter state function. It comes with a transition. If we break that, we will be able to see that we have the target state and the current state all supplied in as data for, hey, where did we come from? What state are we on right now? Because these are just tasks. These tasks can be on any number of states. Any state can be programmed to go into any given other state. And maybe the code on your specific task needs to know something about either the state it's on or the state that it just came from. So this is data that is available to you to work with if need be. Now we have the points that we want to walk to, and we want to have an integer that represents the index of the array that tells us which of the actors in this array we want to walk to. But we don't have a reference to the actual character that's running this state tree yet. And that's actually remarkably easy, because the state tree itself has this context variable. This context variable, in the case of a normal state tree, will just be the actor that is running on. If we make a state tree AI component, like I showed before is possible, this context will be the AI controller that it's running on. This is the only real upside and reason that you'd ever want to make your own state tree schemas, because you can automatically have multiple different new context variables that are going to be a little bit easier to get. But it's a bit of a hassle to set up, so again, don't worry about that. So how do we get this context actor from our state tree into our task? Well, first we need to make a variable that matches the type. So in this case, we'll see our actor is of type actor. If we come here into the schema, we can actually say that the context actor class is a specific type of actor. In our case, this is always going to run on some sort of enemy, and we made this base enemy class. Now, because it is abstract, it also doesn't show up in this particular drop-down menu. So I'm going to disable it being abstract, and now it does show up again. So this way, the type of the context actor variable is going to be BP base enemy. You want this to be as generic as possible while still giving you everything that you need in terms of accessing the variables or all that kind of stuff that exists that you need within the state tree. We might make some variables in the future on this class, like a bool on whether or not you can see the enemy, something like that. So BP base enemy will work just fine. So now that we know that this thing is going to be a BP base enemy type variable, we just make our new variable that we created, and we'll call that just actor. You can call this anything. It doesn't need to match the name necessarily, but generally I either call this actor or call this context actor or something like that, and make sure that it's of the same type. So we do BP base enemy, and we could just say, hey, let's expose this, because then it becomes an available thing to populate, and we can get the global actor, which is the context variable here, and populate it with that. That works entirely fine, but the fact that this is a context variable lets us automate that process. And it's super easy to do that. All you need to do is go into your details panel for that particular variable and just set its category to context. Make sure that you didn't make any typos. This is typo sensitive. And that way, it's going to automatically say, hey, this actor is a context type. So I'm going to look in my context variables. Hey, I have a BP-based enemy that matches this one. I'm going to automatically link these up. So now when we enter the state, we can just get our BP-based enemy. We can be assured that this is going to be valid, but it's also still always a good thing to just do an isValid check. Never hurts to do. And then because we're running this on the actor itself, and we want to make use of Unreal's built-in AI navigation, the AI navigation relies on the AI controller. So what we need to do is we need to get the AI controller from this actor, and this can move to actor. And this has a couple of different ones. We have move to actor, we have simple move to actor, and we have to move to actor or location. For this one, we're going to be using this bottom one. And the reason for that is because it is latent. And that allows us to have these two different other output nodes that don't run immediately. We've talked about the latent node for delay and retriggerable delay before. The thing is, these other two work fine if you just need to set it and forget it. Just say, hey, move to it, and I don't really care about when you finish or where you finish or whatever. These work entirely fine for that. This one is a little bit more powerful because it also has this output on when it finishes moving, or potentially when it says, hey, I can't move to the location that you're telling me to move to, which is great for things like making this state tree task. So we're going to hook this up. It will be able to take in both a goal location and a goal actor. The way that this works is it's going to prioritize the actor that you give in. So it first checks, hey, am I giving in an actor that is valid? If I'm either not giving in an actor or the actor that I'm giving in isn't valid, it will fall back onto moving to the location that you give in. So we've got this points array, and we can get a entry out of that. So we can get a copy. The copy that we're going to be getting will be the integer value. We supply that in, and that's going to be the goal that we move to. Then when we finish our move, that means that we've completed our task. So we can just finish the task. You'll be able to tell it whether or not it succeeded. So we can also hook up a finish task to onRequest field and say, well, this one actually not that successful. And the state tree will be able to handle different transitions as a result of that. You can say, if you succeeded in your task, you move to this other task. If you failed your task, you might want it to transition to something else entirely. And this is pretty much everything there is to making this task. It's remarkably easy. Now, there's one more thing that we need to talk about, and that is how we're going to be giving in this integer, right? Because I can just make this a exposed variable as well, and it will be a thing that we can just put in here. But this will be a hard-coded value. I can just put in 1 or 5 or whatever, but we want this to be a value that keeps ticking up and that we keep increasing, such that it loops around the array that we're working with. So this is also going to become a parameter. But if at any point you make a state tree task that you don't want to be able to give in a hard-coded direct value, and it's always going to have to come from either the outputs of a different task or be connected up to a parameter or something like that, you can build in a little bit of protection so that whoever is using your task doesn't just mistake this field for, well, something that they should use, and it just removes this field entirely. And the way that we do that is, much like we marked this actor reference as a context type variable, we can mark this as a input. So just go into the category again and just type input. Again, make sure that you don't make any typos, but if you do that, you will see that we no longer can give in a hard-coded value here. The only thing we can do is hook this up to existing values. In this case, we're going to promote it to a parameter, and we'll call that parameter, just click on it and rename it, the point index. It's going to be the index for the point that we want to walk to. Now we do need a second task that's going to take this and increase it. So let's do that. Let's make a new task. You can see that we also can make a new task that builds off of our move to target actor now, because that's a task that we've made. We'll just make one that builds off of the blueprint base again though. Call it STT increase int param. And this is going to take in, once again, a variable, and this will be our int parameter. Now, state tree tasks can take in references to a parameter to read from it, but more importantly, to update it. You don't want to just say, hey, we're going to take in an integer. It's a specific type of variable that is called a state tree property ref. Now, once we have that selected, we can expose it, compile this, and this will be able in the default value to also let us say, hey, what type of reference are we going to be working with here? So we want to have this as a reference to an integer. We'll come back and actually program the increasing for this in a moment, but we're going to go into our state tree here and add this task onto our second state. We add a new task, the task that we just made, and we can see that this takes in a, well, integer parameter. So we can choose from the parameters, the point index, and it takes that in. Let's call this increase integer. We also want to take in the actual points array because we want this to never increase to a value beyond how many things are in this array. Let's also take in the array, and that's just going to be a actor object reference array. And once again, we don't want to manually give this in values, so we want this to be part of the input category. Now, the input category is a little bit weird with arrays because you still can just add your own entries to them, but you just can't give them values anymore. You do need to just go into the parameters and say, this is the array that we're working with. Then back in our increase parameter task, we want to override our onEnter state. Here, all that we need to do is we need to get our integer parameter, and we can get the property reference from that. Now, this gets us an output that first checks, hey, did this succeed or fail? If it failed, we can just finish the task unsuccessfully. But if it has actually succeeded, we can take this reference and we can set by ref var. This lets us set the parameter or the variable that we got from this property input to whatever value that we want it to be. Right now, all that we really need to do is we need to just add 1 to it. However, to make this a little bit more future usable, what we're going to do is we will promote this 1 to a variable so that we can maybe at some point we need to make something that can add a variable amount to it based on other data that is given in. Or maybe we always want to add 5 to a certain property, something like that. So let's call this amount to add and hook this up into the succeeded bin. And that really is everything there is to it. We also want to finish the task, but this time successfully. After we've done that, it's pretty much as simple as that. So now we have this, we have the amount to add. Notice that I didn't make this an input because we do want to, in this case, be able to just say, I want to add 5, or I want to add 7, or I want to add 0, which is kind of useless, but we're going to be sticking with adding 1. Now, to protect this thing going beyond the length of this array, what I want to do is just get the last index from the array and check, hey, after we've set this integer to its new value, is this now larger than the last index? So reference goes into the top of our greater than pin and the last index goes into the bottom. Because if it now is larger than the last index, we've gone beyond however long this array is. So we just put that into a branch node. If that's false, we can just immediately finish the task because we're still within the array. If it is true, what we want to do is we want to set the integer ref again. So just copy that over, make sure that the reference here comes from our get property ref all the way to there. And we're just going to set it to 0. That's going to be back to the start of our array. Now, there's a bunch of different ways that we can do this, but this is probably the easiest to understand method of doing this. And now we have a patrol task that will be able to take in our point index and our array to move the actor that this is running on to the corresponding point. And then we have a task that increases that while staying within the bounds of that very same array. So what we need to do now is we need to make a bit of a loop that loops between these different states. And that's where transitions come in. We can make a transition by just clicking on any given state and just adding a transition. This has a couple of different triggers. We can trigger it whenever a state completes. So that is just finishing any task within a state. States can have multiple tasks, and we'll maybe get into that a little bit in the future. But when any given task within the state finishes, it will trigger on completed. It also can use that completion success to either only trigger when a state succeeds or when it has failed. Again, a state succeeding or failing will happen when any given task within it runs this finished task with success or with failure. There's a little bit of tweaking that we can do here. We can say on any individual task whether or not it should be considered for completion. So if we add a task and we're like, we want to run the effective code from this, but when it finishes the task, I don't want it to finish the state in this particular case. We can just click on this, and when it goes to this gray minus, it's going to just not be considering the finishing of this task to be valid for finishing the state as a whole. Moreover, if we come over into this thing that says any, we can choose on when it considers a state to be completed. When any of the tasks within a state have been finished, so that is just the first thing that finishes that is considered for completion, it will consider the whole state to be finished. But you can also say, no, wait for all of the tasks within this state that are considered for completion to have completed, and then we consider the state as a whole to be completed. For now, we only have one task, and it will be considered for completion, and we'll always, no matter what, whether it failed or it succeeded, we want to just transition to our next state. So we'll go with onState completed. We can also do this with a delegate, an event, or on tick. We'll probably circle back to those in future uses of state trees. For now, onState completed is generally the most common way to do this, along with the success and the failed variants of it. Then we can choose on which state we want to transition to. By default, this is going to say root, but we can choose the next state in our list. This is just going to go the next state down, that is within the same group as this state itself. So let's say that this wasn't part of this group that is under root, and instead just need to juggle these a little bit. It exists visually below it, but it's not considered the next state because it is not part of the same parent. You can very easily check that just by if you collapse whatever this state is attached to, does it also collapse down whatever is below it? If it doesn't, it's not considered to be in the same group within the same parent. So next state will not work. However, we do want both of these to be under the root, and as you can see, now it actually collapses both of them. And if you hover over this, it also will say the next sibling state, the next state with the same parents. That's what siblings are, right? Now we also have the next selectable state. So if you have multiple different other siblings within this same parent, and well, just the next one isn't enterable, this one will just go through in the same way that this try select in order does, and it's just going to try to enter this. And if it can't enter this, it's going to try the next one, and the next one, and the next one, until it either runs out of siblings, or it finds a state that it can enter. It does that just in the order from top to bottom. We can mark the tree as a whole to be succeeded or failed. That's going to stop the execution of this state tree, which is very useful for when you're running state trees within state trees, which we might look at in the future as well. But more importantly than any of those, we can explicitly say, hey, go to this specific state in this state tree. So in this case, after we finish patrol, we're going to go into increase integer. We walk to somewhere, we finish walking, we go to increase integer, we do that. We, once again, add a transition when this is completed. We can go back to the root if we wanted to, and then the root will select the patrol state again, and that already creates our loop. We also can just straight up go from increase integer back into patrol. And this now creates a loop. Patrol, increase integer done, go back to patrol. This done, go back to increase integer. And now we've created a loop of behavior. You also can add conditions to these transitions. So for instance, if you want to only do this when the player is inside of the enemy, or when the enemy has below or above a certain amount of health or whatever, you can add a condition to this. And if this condition isn't met, it will just try to go on to see, hey, whatever is the next state transition that I can try. So it does these in order as well. Let's add one more state in between these. So we can just add states, child states, put these in between. And I'm just going to add a delay task to this. It's going to be duration 1 second with a random deviation of about 0.2. And here you can see why moving to the next state might be nice, because I just added something in between here, which is annoying because now I need to go back into this state completed. And now I need to go into, okay, go into this state. While if I just say, hey, go into the next state, it's just always going to go into whatever is under it. So if I want to add even one more thing before the delay now, it will just go into that instead. And the same thing with after the delay. After the delay is done, I just want to move into whatever is directly under it. And this way we can make a sequence of things to do a little bit easier. That's a lot of me talking about a lot of different things. So let's look this in practice. We're going to go into our BP enemy 1, and this is just going to get the state tree that we just made as its value. You will see that we can either turn on or off start logic automatically. By default, it will just, well, start its logic. If you turn this off, you need to explicitly start it by just going in, dragging in your state tree, and you can just start logic. Not much more to it than that. But we're just going to make this start automatically, which means that the moment the game starts, this state tree is going to start running. Let's drag one of these in, and then select the state tree, and give in some points for this thing to walk to. Unreal has a pre-made actor, just called target point, that is pretty much just an actor with nothing in it, aside from a little icon that you can click on that will represent a point for an actor to walk to. So let's just add 3 of these like this, and we can go into the state tree, add 3 entries to this array, and say this is number 1 that you're going to walk to, this will be number 2 that you'll walk to, this will be number 3 that you'll walk to. Save everything, and let's run this. So we can see that he still does not move. Why is that? Well, that is because for AI navigation to work, we need to give it some information on where it can and cannot walk. And we do that by adding in a nav mesh. So we can just, in our place actors here, find a nav mesh bounce volume. We drag it into the level and press the P key by default. We'll be able to see this green little overlay. Everywhere that is colored green is going to be covered with what is called the nav mesh, which is an area that AI can use to walk on and to navigate, find their way to where they need to be. So let's make this just a little bit bigger, big enough so that it covers everything that it needs to cover. And you can see, because it sees, hey, there is an obstacle here, the nav mesh actually generates around it. It knows that, hey, I can't walk here. So the green area says, well, that's unwalkable. That's not going to be considered as part of the nav mesh. Pressing the P key toggles that view on and off. If we try again now, we'll see that he actually does walk from point to point. Now he should be going back to point 1, and we've got our basic patrolling enemy working now. Now, he doesn't do anything else yet. He doesn't get aggressive when we come within a range or when he sees us or anything like that. That's going to be a thing that we take care of in a future video. But for now, we have set up the basics of getting started with Unreal's state trees to build AI. There's a lot of information in this video. I do have a dedicated series as well to breaking down state trees a little bit more subject by subject, which if you're really having trouble following along with this video and what we're going to be doing in the next video as well, it might be a good little side adventure to go through that real quick. I still will cover everything in this as well, but what we're doing here is much more geared toward actually using things to make them and explaining things as we run into them, while that series is much more geared toward taking all the features of what state trees are and just one by one highlighting and explaining them in a vacuum, which helps a little bit more with the information overload that you might have in examples such as this. Just play around with it a little bit, and next time we'll be moving on with making this guy actually be able to see us and start running toward us when we're in his range. Now that we're AI professionals, after making a character that can just walk from point to point with our state tree, let's make him respond to being able to see us. Because right now, he's just doing the same sequence, and it's not really very artificially intelligent yet. It's actually pretty artificially dumb. We want to look into AI perception and hooking that into the state tree that we started making last time around. So let's go find this character in our project, and we're actually going to go one step up and back into our base enemy class, because every single enemy that we make, we want to have some sort of perception, and we'll add a new component to it. We can add an AI perception component. Now we have an AI perception and an AI perception stimuli source. We just add the AI perception, and here we can add in the senses that it has. So in the detail panel with the AI perception selected, we have this senses configuration. Add a first sense. You can add multiple senses if you want to. For now, we're only going to make it see, but you can also add things like hearing. So when your character makes a sound through the stimuli source, it will be able to react to the hearing of that sound as well. And it can maybe hear sounds from further away than it can see, or maybe the other way around. There's a couple of different senses that we can have. We can have a team affiliation sense as well, a damage sense for when it's damaged, all that kind of stuff. Again, what we're going to stick with for now is going to be the AI site configuration sense. This has a couple of different settings. It has a implementation. You can add your own site implementation if you wanted to, but we're not going to do that because the one that it comes with is actually pretty good. It has a radius in which it will be able to see. We're going to set that to a lower value for now, just down to 1,000, which is pretty small, mostly for demonstrational purposes. And then it also has a site lose radius. So if we imagine that we have a 1,000 unit circle around this character here, if we walk into that, and we immediately walk back out of that 1,000 radius, it still is going to be able to see us because it has picked up on the fact that we're there. So its focus is on us now. So logically, it makes sense that it would be able to see us for a slightly longer distance after that. So we need to walk away to maybe all the way over a radius like this to get to a safe area where it can no longer see us again. So this loose side radius is going to be a slightly gray zone area where if we step into it, it won't be able to detect us, but we will need to get all the way out of it in order to lose that aggro. So let's make that 1,500. Generally, just a little bit bigger, like 10, 20, in this case, all the way up to 50%. Larger than the side radius is a good rule of thumb. We have its peripheral vision, so how big is its view cone? It's just going to be 90 degrees all the way up to 180. Stick with 90, that's pretty good usually. Now we can detect by affiliation, and this affiliation system is kind of a little bit weird because it doesn't work that well if you're working with blueprint only for the most part. Because we have this detect enemies or neutrals or friendlies. But since we're not going to be setting up a team base here, we just want this to detect neutrals and just detect friendlies as well. Just turn everything on. That way it's not going to be a problem. And we can disable or enable configurations for senses as we go. So we can also say, hey, does this one start enabled or not start enabled or whatever. Give it a debug color, all that kind of stuff. We can give it a dominant sense. So that's the sense that it's going to give priority to if it has multiple different stimuli at the same time. And for us, that's going to be, well, sight. So now this character will be able to see, which is quite nice. If we now play the game and I press the apostrophe or the quotation key, usually above your right shift on the keyboard, we get the AI debug mode. And I'm going to turn on with numpad 4 the perception. And they will be able to see the green is the perception radius. So this is where it'll be able to see us. And the red will be the perception, well, losing radius. We also have those lines coming from its, well, facing direction. And its peripheral vision being 90 degrees means that it can see 90 degrees to the left and 90 degrees to the right. So that means that its actual view cone is 180 degrees in front of it. And you can see when I walk into its field of view within its range, it can keep track of where it saw me, and when I leave its range, it keeps remembering the last place that it did see me. That's where this maximum age comes in. We can say, hey, after 5 seconds, if you haven't re-seen me, I want you to forget the last known location for this guy, which is quite nice. So now we've got a character that can see. So whenever we see the character, we need to send a message to our state tree to say, hey, we've just spotted the player. We probably want to do something with that, right? And the way we can do that is with the AI perception component selected, going down into the events. We have a couple of events here. The on perception updated, when we forget a perception. So when this max age runs out on a stimulus, we can run an event in response to that. On perception target updated or on perception info updated. I'll just show you on perception updated. This gives you an array of actors that this component is perceiving. What I usually like to do instead is on target perception updated, because this will run every time a target either enters or leaves the sight area of this AI perception component. So this will be the thing that we either started seeing or stopped seeing. And this stimulus will be the AI stimulus that is relevant in this case. If we break this, we can see the age of the stimulus, the expiration age, the strength, the location of where it happened, the location of the receiver, a tag that might be related to it, and most importantly, whether or not it was successfully sensed. This means that, for instance, with sight, if we enter the range of our AI perception component, this will be a true value because we successfully have been sensed. This will also run this exact same event when we leave that perception, when the AI can no longer see us, and then this successfully sensed value will be false. So what we'll do here for now to keep this simple is, first and foremost, we're just going to check if the actor that we sensed is going to be equal to get player pawn. We don't want to worry about it being able to sense other AIs and do stuff with that. We just want to kind of like gate this off. Only when you start or stop seeing the player do we actually do anything with it. Then we do something different depending on whether or not we started seeing or we stopped seeing the player. So we do one more condition here, and we hook in the successfully sensed into the true pin of the first branch. With that, we can drag in our state tree here, and we can send an event to the state tree. We can split the structure pin for it real quick, and we'll be able to see we have an event origin, which is a name. We have an event payload. We're not going to worry about that either for the time being. The most important thing is the event tag. This works off of the gameplay tag system that Unreal has, and it's a super powerful system. This is essentially a way that we can identify these different events. We can say we're going to send an event with the tag, let's call it maybe perception player spotted. And then in our state tree, we can just wait for an event with that same tag. And then these two things can work together, send messages back and forth, or at least from the blueprint to the state tree, without them being hard-coded or linked together in any way, because they both understand what these tags are and what they mean, while still being able to function independent from each other. So we can just add a new tag by pressing this little icon here, this plus icon, and we'll add a tag that's called AI. We need to give it a file that's going to keep track of these tags within. Usually you just put that in this default gameplay tags.ini. You can make your own ini file with your own specific gameplay tags. It's a little bit more organized once you start having a lot of them, but for now we'll just put them in the default one, and we add that new tag. And now we have this tag called AI. Clicking on this, we can add a sub tag to it. So we'll make a AI.sight, add that as a new tag, and now we have that as a sub tag. Sight is part of the AI hierarchy of tags. We might get a little bit more into that in the future. I have a specific video talking more about gameplay tags as well, if you're interested in that. It's a really powerful system. But for now, I'm going to add one more. You can just also add these by just typing them out. So AI.sight.scene, add that as a tag, and you can see that it adds it into the hierarchy. I can also add AI.site, make sure that you do have the capitalization properly, .site, .unseen, something along those lines. And now both of these are subtags of site, which are both subtags of AI. The wonderful thing is, if I make a state tree now that isn't looking out for specifically AI site seen or AI site unseen, but maybe all I care about is that something about the site happened. I don't care whether it's been seen or unseen. That state tree can look out for AI.site, which will get triggered both when the AI.site.seen or AI.site.unseen is sent through. That's why this hierarchical system of tags is really quite nice. For now though, we're going to just look out for specifically entirely AI site seen and AI site unseen within our state tree in a moment. So after this branch, if this is true, we send through a state tree event with the tag AI site seen. And if this is false, we make our state tree send an event, and that will be of type, or with the tag rather, AI site unseen. And just to show you that this does work, I'm going to add in a quick little print string here. And it's going to just print the value of the stimulus source. So whether or not we have been seen or unseen, so true or false. So if I walk into this guy's vision, you can see it's starting to print true and false, just like that. But now that we have all of that set up, we can go back into our state tree and we can start making a second state that will chase toward the player. We'll do something about player attacking and having player health a little bit later. But for now, it's just going to try to chase the player, and when it no longer sees the player, it's going to, well, just stop chasing the player. And for that, we need to start splitting this into two different substates. Let's give this a name actually, just like delay. And we'll make one more child state to the root. And everything that we've made so far, the patrol, delay, and increase integer, is going to go into this state. So now we've got one state that encapsulates our whole normal patrol routine. And this is where state trees come in, being very powerful compared to behavior trees. Because we can now make logic on this, like a task or transitions that we're looking out for. And as long as we're within any of these states, whatever this state has going for it also will be active at the same time. So we can have a couple of things layered on top of each other that will work together or work in parallel to each other. We also, when we drag and drop these things, need to make sure that they're drag and dropped into the right order. Let's rename this to move to target so that we can easily name this one patrol instead. And everything in here we can just kind of leave alone, so we don't need to worry about any of those. Then we add in one more child state, and we'll call this one chase. Now, as long as we're in the patrol state, which includes, again, being inside of any of these three states, we want to have a transition that when we receive the event with the tag, so you can open up this required event, and we can tell it what tag to look out for. So we want to look out for the tag AI site seen. Then we want to transition into some other states. In this case, we're going to be transitioning into the chase state. So transition to chasing. For chasing, we're going to need to have a new task that we make. So let's make a new task real quick. State tree task blueprint base, and call that STT chase targets. And this chase target is going to be super similar to the move to target that we made before, but this is a thing that just moves you through an array of points. But we still do need to get the actor, which is going to be a context variable, get the AI controller from it, and then just move to a location or actor. So let's rebuild that. We make a variable called actor of type actor object reference. Make sure that we mark that as context for the category, and don't typo it like I did, because again, it is very sensitive to being typoed. And then we give it a target that we will move to. This one, we always want to give in a input reference that we get from elsewhere, no manual values that we want to like just type in. So we give it the category of inputs. We also want to give in a fallback target location, and that's going to be a vector. And this one also we want to be of type inputs, because whenever are you going to explicitly type in the location that you want an AI to move to within the state tree, you always want that to just be some type of variable. Maybe its original starting location. In this case, we're going to be using this for moving to the player's last known location when we lose sight of him. When you mark something as an input or a context, by the way, you don't necessarily need to make them exposed. It'll just do that for you, so don't worry about that. But it also doesn't hurt to do it. Now, with that out of the way, we can make our state enter. And there we very easily just get our actor. Again, it's just good practice to get used to making sure that whatever you do with actors is valid. When you have an actor reference, you can actually just convert it to a validated get, and it combines this into just one node. It's kind of nice. So if this is not valid, we finish our task unsuccessfully. But this is always going to be valid, so it's fine. And this will actually be of type BP base enemy. It's going to change variable type, so it's going to give you a warning like, hey, this might break stuff. It's not going to break stuff in our case, so it's fine. And then from there, we can get the AI controller. We can move to location or actor, which is this one down here. And in here, we're going to give in both our target actor and our target location. Once again, if it has an actor that's been given in, it's going to prioritize going to this actor. And another thing that's really cool about this move to actor or location node is if you give in an actor and that actor is moving, it's going to chase that actor while it's moving. It's not just going to take the location that the actor had when they started and move to that location. It's going to actively try to catch up to a moving target. The target location, though, is just the value that you give in. It's going to move to that. Then we just do on request fail. We finish the task with failure. And if we succeed, well, we succeeded. So super cool. Now this chasing state. We're going to add in a couple of child states here. So the first one will just be chase player. This is going to have the task that we just made. So it's going to take in the chase target. And now we need to give it in a target. How do we give it that target, right? How do we get the reference to the player? We can't just get player ref in here. That's not a thing that we can do. So we need to get it from somewhere, some way. You also notice that this actually doesn't compile as long as any of the inputs that you have marked as inputs don't have a value, which does mean that it probably is actually a good idea to make this target location not an input, because sometimes you're not going to be using that. And the same thing kind of goes for this target actor, because sometimes we're going to be filling in the location, sometimes we're going to be filling in the actor. So it's probably good to, I don't know why I made that context, I wanted to make that default, to set both of these back to being defaults. And now you will see that it compiles, no problem. That doesn't change the question though, is how are we going to get our reference to our targets? Well, we can do that in a number of different ways, but for now, I think what makes the most sense is go back into our BP base enemy and make a variable here for our targets that we're going to be chasing. That variable is going to be a simple, just actor object reference. And whenever we have done this perception updated thing and we've made sure that it is the player character, instead of printing this thing, which I just did for demonstrational purposes, we can drag in this variable, holding down Alt to get a setting node, and set it to that value. Now this actor has a variable of the proper type, and if we go back into our state tree, we can access that variable from our state tree. Because our context actor type that we set here, the context actor class, is our base enemy, this functions as a cast to that class. We've used casting nodes a little bit in the past, which means that we can access the variables that exist on that class. And with that, we can go targets, and we can set it just to the actor, which is the context actor value here. But we also, since we have that, get access to all of the variables that exist on the actor that this is running on. In this case, the target. So we can just say, hey, chase whatever this actor's target reference variable at the moment is. And the actor itself will take care of setting that in this case. So this will now go chase the player. We'll build this out a little bit more in a moment. But for now, let's just give this a transition where it goes back into chase so that it doesn't go back into root. And it's going to get stuck in always wanting to chase the player. But this should mean that assuming that our nav mesh is big enough for it to navigate toward where the player is. So let's just make this nav mesh the size of this entire little map that we have here. And also make it a little bit taller so that I can actually access the areas up here as well. Whenever it sees us, it should get angry and start running toward us. And there we go. It's not going to stop chasing us ever, even if we manage to somehow like outrun it or something like that, because it now has been told, hey, move to the player and just always keep moving to the player. We have no way to exit this aggression loop at the moment. And that's what we're going to be working on next, because instead of this just going into chase, this would likely then go into something like adding a new sibling state, which would be attack, which is probably going to be something that we deal with in the next video. For now, attack is just going to be a quick delay task of a second. And then after attack is done, what we do is we go back into chase player. Creates a bit more of a realistic loop. And that allows us to check, hey, while we're chasing the player, if we lose sight of the player, we want to go to the player's last known location. So that's another state that we want to make within this chasing state. So let's add another child. Move to last known player location. It's very badly mistyped, but that doesn't really matter for now. We'll add in a new task. That's going to be chase target. And here we just give in a target location. If this is just going to run in response to whenever the chase player loses track of where the player is, what you can do is just get a actor location, which is a property function here. And if we open that up, we can just give in the actor reference to our targets. However, if this runs after the attack is done, the player might have gotten out of the sight and even further away in that time, at which point this doesn't really work anymore. Because that means that the enemy is going to magically know something that it shouldn't. And that's where we come back into the AI perception methods that we're using here. Because if we are losing track of our player, we have this stimulus location. This is going to be the last known location of our player. Promote that to a variable, call that last known player location. And we just set that whenever we lose sight of the player. So whenever successfully sensed is equal to false, we set this. Because if successfully sensed is equal to true, we're not going to be worrying about moving to a location, because then we just want to move to the actual actor that we're seeing. So there's no use in setting that value here, because we're not going to be using it as a response to successfully sensing our target. But now that we've done that, we can, instead of doing this target location from a get actor location, we can use our actor last known player location. And this is going to then move to the last known player location. If it ever reaches that location without having spotted the player, then we just wanted to go back to patrolling. Which means we want to add two different transitions to this. First, we want to add a transition on event, which says, hey, when we receive an event here, that is going to have the tag that we've seen the player, which means that in the process of going toward the last known player location, we have regained sight of it. We then want to go back into our normal chase player, like little loop that we've got going on here. So we go transition to chase player. However, if we reach the very end of going to our last known player location, and we've not fallen back into, hey, we can see the player, so we can go back into chase player, that means that the state has completed without us regaining sight of the player, at which point we just want to move back to our patrol. This is almost properly functional, which means that now we need to work on the other way around. We need the chase loop that we have here between chasing and attacking to be able to transition into this move to last known player location as well. For the chase player, that's pretty simple as well. We can just add a new transition, do that on a event, and whenever we lose sight, so the tag will be sight unseen, we very simply just move to the last known player location. As easy as that. But what if we lose sight of the player during this little delay that we have here, that we have as a placeholder for attacking? Because when the state completes, we just always go back into chase player. So we need to refine this a little bit. Once our attack is finished, we need to decide, do we go back into chasing the player, because we can still see him, or do we move to its last known player location, because we cannot, at the moment, see him? And we're going to just make that into yet another variable. Whenever our AI perception updates here, we're going to use our successfully sensed output pin, promote it to a variable, and just call that can see player. This way is always going to, whenever it starts seeing or stops seeing us, alongside with updating our targets, is going to just update whether or not we now can see the player or not. So in attack, on state completed, we now can add a condition to this. Right, I've talked about conditions a little bit before, now we're actually going to be using them. So we add a condition, and there's a whole bunch of different types of conditions. You can make your own conditions as well. For now, all that we really need is a bool compare. We want to say, hey, our left, which is the input here, we're going to take our actors, can see player value. So a whole bunch of values that we can get from here, of course. But this is the one that we made. So we're going to check that, and we're going to check, hey, is that true? If that is true, then we go into just chasing the player again. However, we also want to make a transition on state complete still, where we move to the last known player location, and this should be good enough because it does these in order. So it's first going to check, hey, state completed, is this condition true? If the condition is true, we move to this state. If this condition is not true, then it's going to move on to on state completed, whatever it tries to do here. So this one doesn't necessarily need to have a condition to it. However, for the sake of clarity and making it obvious what you're intending to do with this, I personally do like to kind of be redundant and do add this as well here and just keep the right here as false. So now we can see is can see player false, then we do this one. Again, functionally, this one usually isn't necessary, but it's just nice if you see these on top of each other, you can see, oh, this one is checking true, this one's checking false. And now we've got this little state machine working here, where we have a patrol state, where it just does its thing. It can be taken out of the patrol state into this chasing state, where it has its own little loop that it can go through here. And this will keep going pretty much indefinitely until either during this or after this, the player is no longer seen, at which point it will do one last attempt to find the player. And if it can find the player, it just goes back into this loop until, again, one of these moments happens where it breaks out and goes back into here. And if by the end of this last attempt, it cannot find the player and restart this aggressive loop, it goes back into patrol and just does this until it gets interrupted by being able to see the player again. We've gone from just a character that does a sequence walking from A to B to C to A to B to C to A to B to C, to a character that now can actually respond to the world around it and start making basic decisions, actually exhibit some type of behavior. That, while basic, is starting to approach something that maybe feels more intelligent. So let's see how that works. It's just doing its patrol, just like that. I'm going to enable the debug for the perception, which you can do with the quote key or the apostrophe key, same key. The one just above your right shift key, most likely. However, if I walk into its view range, it's going to start chasing me, which is fine. If I can get out of its range, which is actually kind of difficult because he's walking real fast, he's going to try to find my last known player location, and because he couldn't see me from there, he went back into his normal patrol state. However, when he chases me and he loses sight of me, he's firstly going to try to find where I used to be, and that means that he's going to, well, stick with trying to find me. So let me try to get out of his view range, like that, and there he was able to find me again while going to my last known player location, which means that he can continue the chase. When he reaches me, he actually does something a little bit odd, because it looks like he's trying to go back into patrolling when he reaches me. And that is most likely because we stopped him mid-movement as he was starting to chase me with a different movement. But then when that movement stops and he hasn't gotten a new one, he's going to try to continue the movement that he was doing before. That's not exactly ideal, but pretty easy to fix. Going back into the move to target task here, what we can just do is we can add in a on-exit state. This one will run whenever we just exit the state, whether it be through finishing the task or because a different transition forcefully moves us out of this state. So if we just get the actor and the AI controller and we say stop movement like this, it's going to stop its current movement before starting the next one, which means that it won't try to resume this one whenever it just gets a moment to do nothing. So let's test out if that actually works. If it manages to reach me, it should no longer try to go back to its patrol route. The same thing should also hold true for when we do the normal chase target, because there also is a possibility that it's trying to move to a target location, still in the background. So all that we need to do here is we also add in an exit state to this one. We get the actor and its controller just the same way that we did in the other one, and we stop movements. And that should get rid of the jankiness of it trying to return to different positions as well. And now I think all the jankiness will be gone. So we can get his aggro. He's going to start chasing us. And I'm going to just turn on all the debug stuff so that I can see, like, when he gets to me, he's going to wait for a second. And then if I outrun him, which is actually kind of difficult because he is pretty fast, but we're going to get there. And he doesn't see me again. He just goes back to his normal patrol routine and all that good stuff. So everything should work pretty well now. One more edge case. If he loses track of me and he finds me again, he actually didn't find me there because he's not that smart, okay? He's pretty smart, but not that smart. I was just outside of his range. So let's try to get out of there. He regains sight of me. He reaches me. And again, there's no jankiness because all of the previous instructions for, hey, just keep moving, have been pretty much eliminated. So next time, let's look into making this attack actually do something. Introducing a system with health for our player. We already have a death and respawn system, so we need to hook it into that as well. And like that, we're slowly but surely starting to make this more and more into an actual game. Now, the last couple of videos, we've done some pretty out there stuff. If you're just getting into Unreal, starting with building AI with these state trees, and might have been a little bit complex. And there's definitely going to be merits in playing around with that a little bit more later. For now, let's do something a little simpler again, because we've got this enemy AI that has this sense of being able to patrol between different patrol points, and then when it sees us, it runs toward us and it hits us in the face. It doesn't have any animation for it. It doesn't even actually do anything. All that it does is it waits for a second. That's all that the code for it at the moment does. So instead, let's make him actually hit the player. And for us to be able to take damage, we first need to have some sort of HP system. And that is super easy to do because an HP system is just a number that you subtract until you get to 0, at which point you die. And in a previous video, we've already set up a death and respawning system. So we can just go into our player character blueprint and add in a value for health. We've got all this stuff in our player character, which we are not going to worry about too much for the time being, because that's all platforming stuff that we've done before. So let's just add a variable, and we'll call this HP. And you can make this variable an integer if you wanted to, because we're only going to increase and decrease these in whole numbers. The difference being integers don't have decimals, and floats do. However, the annoying bit is that when you use an integer in some sort of math operation, it also outputs something that is rounded. Kind of annoying. And you might think that's not relevant because, well, if your HP is always going to be round, you don't ever want it to output something that is a decimal. But what if you want a percentage on how much percent you have compared to your max HP? you're going to do a division between your max HP and your current HP, and that's going to output a value from 0 to 1. It's always going to rely on it being a decimal. And those are the kind of values that you use to drive things like HP bars. So even though we're not going to be relying on things actually having decimals in the values that we're going to be using directly, it still makes sense for this to be a float. Integers really only ever are used for the purposes of counting things. If you're going to be using something extensively in math operations as well, a float very quickly does make more sense. And as I mentioned, we have a HP amount, but we also will have a max HP amount. And this is going to get annoying, right? Because if we have 10 different stats, we're going to have a normal, like a current value for it, and a max value for it. So let's try to group these together into one single variable instead. I'm going to delete the HP and the max HP. And what we're going to do is I'm going to just in my tutorial folder itself, right click, go into blueprints, and we can make a structure. We've talked about structures a little bit before. A structure is a packaged together combination of variables. So we'll call this BPS for blueprint structure. And we'll just call this stats. Because if we want to add a mana stats or maybe a stamina stats or something like that in the future, we'll be able to just add multiple of these. And we're going to add just a couple of floats to this. So we'll add a minimum value as well, because sometimes maybe we want our minimum value to be below 0 or even somewhere above 0. It's just a useful thing to have. We'll have a maximum value, and then we'll have a current value. And now we have this as a variable type that we can make, well, variables of, that's going to have a slot for a minimum, a maximum, and a current value. This way we can just send through this one variable to things like our UI in the future. And it's going to be able to just take the maximum and the current value and all that from this one packaged together structured variable, instead of us individually having to make a bunch of different floats and individually send them through. Just prevents a lot of tedium. It doesn't actually do anything majorly different in terms of like unlocking new capabilities for you. It's just convenient. So now that we have that, we can make our HP stat again. And this time it's going to be of type BPS underscore stats. And you'll see if I compile this, it has a little drop-down menu and it has a minimum value. It's going to be 0. The maximum value, let's say that that's going to be just 5 for now. And the current value, we can also manually set this to 5. That works well enough. Otherwise, what you might want to do is just in begin play, set the current HP to the max HP. Whatever floats your boat, doesn't really matter. I'm going to just stick with doing it this way for now. So then, how do we receive damage? Unreal actually just straight up has a built-in damage applying system because, well, it's a game engine and games usually deal with some sort of damaging, right? So it has that built in for us. We have a event damage, and there's a couple of different types of damage. There's point damage, there's radial damage, and there's any damage. Things like point damage will give through extra information on exactly where you were hit. So if you want to modify the amount of damage that you're actually taking based on maybe if it was near a head or near a shoulder or just in the feet or whatever, point damage works quite well for that. Radial damage is stuff like maybe a grenade exploding. If you're very much near that, you're going to take more damage. If you're a little bit further away, you're still going to take damage. It's just going to be a little bit less. And then any damage is a more generic version of this, which just responds to, well, any sort of damage being applied to the character. It has a lot less extra information that it's giving through, but it doesn't need it because it's fairly generic. It gives through the damage that was dealt. We'll do a little bit more about that in a moment and show you how to send this stuff through in the first place. We'll get a damage type. We're going to be mostly ignoring that for now. We'll be able to tell who this was instigated by. So this is the controller of the actor that damaged us. This mostly comes in useful for when you're doing stuff like multiplayer online games. You can see that it has this little icon that it runs on the server. We're not going to dive into multiplayer and replication stuff because it complicates things quite a bit. Still, if you have something on like an AI controller, this can be useful in single player games as well, but generally speaking, it's just a damage causer that you care more about. This is the actual actor in the world that caused the damage to you. For now, all that we really need to do is we need to get our HP, and we need to set a member in this structure, and that gets us this node which has no other inputs. If we go over into the details panel, however, we can enable different inputs from our structure, so we're going to be setting our current value. This way we can update individual parts of our structure without affecting the other ones. Because if we just try to do a setting node here, we can break this structure pin, but then we would need to supply in the minimum value and the maximum value again, even though we're not really changing those. And again, that's a thing that you can do, but it's just a little bit more tedious, especially if you have a struct with a bunch of different values, like 10, 20, 30 different variables all packaged together within it. It becomes tedious to hook all of those through, while you also could just say, hey, I only want to set this one member and everything else, leave it alone. Well, we can get the HP and we can break it apart into its separate components like we've done with other structs before. And we can get our current value and subtract just the damage that we're taking in from it, and set that to our new current value. But what if we've taken in 2 damage and we only have 1 HP? We make this minimum value for a reason, right? We want this to never go under our minimum value. So what now? In order to do that, what we can do is we can get a max float node. And what this node will do is it will take 2 inputs and give an output of just whichever value was higher. And at first glance, you might think that doesn't sound intuitive at all. We're trying to ensure a minimum value. We're using a node that is called max. That's weird. And you're kind of right. At first glance, it isn't intuitive. But this thing isn't called max because it will ensure a value doesn't go over a certain maximum value. This is called max because it gets the maximum value between its inputs. It just so happens that that is then often used to clamp things between a current and a minimum value. If you just put some actual numbers to it for your own example in your own brain, it might start making a little bit more sense. Let's say that our minimum value is 0, which it is, and the output from this subtraction would be 3, because we just got some damage and now we're down to 3 HP. We put in the minimum value of 0 and our newly calculated value here of 3, and this will get the maximum between 0 and 3, which is 3. So that's all good and well. However, let's say that this subtraction, we got so much damage dealt to us that we went way below a value of 0 even. So this minimum value still represents 0, but now this max node is going to compare 0 and -2. 0 is actually a higher value than -2, because -2, well, is negative. So now this thing is going to output 0. So with those numbers as examples, hopefully it makes a little bit more sense why we're using a node with the word max just in all caps on it to figure out a minimum value. Again, it makes sense if it is a little counterintuitive to you, but hopefully if you just try to figure out things with these example numbers, which is a thing that's often good to do. If you feel like you're not properly grasping something or you're a little hesitant on if you understand how something works, just try to run through it with some example values. Either way, that tangent out of the way, we just do this, and now we have a way to damage our player. We then also want to check our HP again, so let's just split this structure pin. And now if our current value is less than or equal to, it shouldn't ever be less than, because our minimum value is set up here, but it's still always good to check less than or equal to. It's not that much more expensive for the way that we're using it here, so just use less than or equal to. But we're going to check if it's less than or equal to 0, because if so, we're dead. And we already have a kill player thing here somewhere, I believe. So yeah, we have a kill player function, and that is just going to run in response to that. However, kill player just resets us to our respawn transform at the moment. And we also need this to set us back to full HP. So what we're going to do here is in kill player, we once again get a reference to our HP. We set a member. We're going to set our current value to break our HP reference and get our max value. This time, anytime that we respawn, we also respawn again with full HP. For demonstrational purposes, I'm going to look at where I put my event tick. It's a very disorganized little thing that we have here. Do we even have an event tick on this? We might not. I don't think we do. Let's just add one. And I'm going to print string the value of our split structure pin here, current HP. Nice little tip. If you're doing this print string in event tick, you're going to spam a lot of these. So a nice way to prevent that is to just give this a key. Just type in something like HP print. And that way, whenever you print a string with the same key as a string that's already being printed for debugging purposes, it'll just replace it instead of printing a whole bunch of them under each other. And we should see that I now have 5 HP on my print string. All we need to do is give this guy a way to attack us. And we already have his state tree pretty much figured out. If you have something selected in your world view, by the way, in your viewport, you can press Ctrl and B to browse to wherever the blueprint exists in your project. Nice and easy way for me to find this state tree right now. We have this attack, which is all good. And I'm going to increase the duration of this delay to a little bit longer. We need to add a task alongside of this delay that will now damage the player. If you have attack animations, which we will do at some point in the future, you would play that animation and then have the animation handle the timing of when you're doing like a line tracer or a sphere overlap to check, hey, am I actually physically hitting the player? Am I close enough? So that you have some timing and you actually get, and you properly get some gameplay going. But for that, we're going to need to have animations, which is going to be something that we'll look into in the future. So for now, what we do is we just make a new task, blueprint base, state tree task, STT, core damage targets. And here, all that we really need to do is we need to take in the targets that we're going to be damaging. So we do enter state. We have a variable, call that targets, and that's going to be a just actor reference is all that that needs to be. Make that category inputs, because that always needs to have a value. And here comes the amazing part about Unreal having this build and damage system, because we can just apply damage. And here we have those different types as well. Applying a point damage, radial damage, or radial damage with a fall off, or just a generic apply damage. The event any damage that we created before will also run as a response to apply points and radial with fall off. Obviously, the point damage will only run as a response to getting point damage. The radial will only run as a response to either radial or radial with fall off. We're going to keep it simple though. We just apply damage. Again, this is entirely handled on the server side if you're doing something with multiplayer online stuff. And we just can give in all the values that we saw back in, where did we put it? Here as well. The damage type, the instigator, the damage causer, the damage, the instigator, the damage causer, they're in a different order, and the damage type. So let's promote this to a variable. Just expose that as base damage. The instigator will be the controller of whatever actor is doing this, and the damage causer will be, well, the actor that is doing this. So we'll also need just a actor that's part of the context, as we've done in previous state tree related videos. And this actor can be the damage causer. And then if we get the controller from it, we can put that into the instigator. You don't necessarily always need to fill these two out, by the way. You can just leave those empty if you don't care about using them. But now back in the state tree itself, when we enter the attack state, it's going to start delaying. It also was throwing some arrows at us, so ignore that for the time being. But we can add a second task alongside of it. This is the first time that we have a state with more than one task. So what this is going to do is it's going to delay for 2 seconds and then also run our damage targets, which is going to apply 1 damage, and the target is going to be our actor's target, because we keep track of the target on the actor itself. Now, the damage target doesn't have a finish task in it at all. So whenever it runs into the end of this code, nothing is going to happen. That can be fine, but generally also it is a good idea to add in a finish task, even if you don't intend this thing to be finishing the state as a whole. And that is purely for, again, just clarity reasons. We can turn this thing off to not be considered for the state completion. And that way it won't actually complete the state when this one finishes running. We could also say, well, we want to wait for all of the tasks to be completed. And now, if this damage target takes longer than 2 seconds, which it won't, but let's pretend that it does because it has a long animation. What we've now done is made a state that lasts at least 2 seconds, but potentially longer depending on how long the animation that we could run inside of this task does. Because it's going to be waiting for all of the tasks within it to be finished before the state as a whole is considered completed. And let's see if that all works. We can aggro him to me and he damages me. I can run away, and after 2 seconds he starts chasing me again. And at some point he's going to, well, make me run out of HP. So 2 seconds, attack again, 2 seconds, and I respawn with full HP back at the center, and we have an HP system. A very rudimentary, a very simple and straightforward HP system that doesn't have any proper UI yet. We'll deal with that in a separate video. But we've got HP. And we've learned about the damage system. We've learned about structs. We're starting to learn more about this engine every single video that we go through. While we have HP now, it's being printed as a print string, and that's not great. We can see it goes down as we get attacked, but this is not something that we can ship into a game. We need to incorporate this into UI in some way, shape, or form. We've already done a little bit about UI in the past, so if we go into my tutorial folder here, we've made a UI folder in which we've just made a general HUD widget blueprint, and in that we're taking care of displaying the amount of gems that we've gotten. I'm actually going to make this one a little bit smaller because it's rather big on screen, all things considered, and I'm probably going to move it to the bottom left corner instead, because the HP bar being at the top left, to me at least, makes a little bit more sense. So just roughly move this down here. Since we moved this down here and the anchor is still up here, we also want to move the anchor for both of these elements down to this corner so that they always stick close to the bottom left corner. If you put something in the bottom left and it's going to be anchored to the top left, it's going to scale weirdly and maybe even get pushed off screen. We don't want that. So now, how do we make this in a way where we have an HP bar that updates whenever we get damaged? We're going to make this in the most straightforward and easy way possible, and that is by just using Unreal's built-in progress bar. Add that to our canvas panel, add our progress bar, we'll keep that in the top left, and we'll make that something like this big. A progress bar is just a pre-existing widget that we can give in a percentage to, and that percentage goes from a value of 0 to a value of 1, and as you can see, it just fills it in with a color. We have a couple of different fill types, left to right to left, fill it from the center, sure, horizontal from the center, vertical from the center, top to bottom, and bottom to top, whatever you really like. I'm going to go left to right because that's how almost every bar ever works in video games. More importantly though, we have in the appearance here the fill color and opacity. Since it's an HP bar, I think it makes sense to, well, make that green. You can do a lot of work to make your own custom HP bars and display a lot of fancy other type of stuff. We're just gonna stick with this for the time being. The default value for this will just set to being entirely filled, because usually we'll probably have our HP bar being full at the start of our game. And here we can make this work in one of two different ways. We can either, whenever we deal damage to our player, tell our HP bar to update, or we can update our HP bar whenever our HP gets updated. That might sound like the same thing, and in practice it kind of is, but it is about the direction in which our blueprints communicate. What we did here with the gems before is we're looking at our tutorial game instance and we're updating our little text here whenever we update the score. We work with an event dispatcher there, and this oftentimes is the way that you set up things like UI. When building a UI, the way that you want to think about it is that it itself generally shouldn't be handling too much in terms of logic, and actually just doesn't contain too much in terms of code if you can help it. Of course, there are UI elements that need to interact with player interaction and have some code as a result of that. Whenever you have like a button that needs to open up another menu or do something, of course, that's going to have some amount of executing code. For the most part though, these UI elements, especially if we're making a HUD, they should just take in information from different objects, game instance, player character, and just display those. If we make the player character tell the UI to update, then that player character specifically tells that specific type of UI to update, which can be fine, but also somewhat limiting. If we make the UI look at the player and say, okay, I'm going to be looking out for this thing happening on the player, then you can have multiple different types of UIs that you switch in and out depending on different situations or different player characters or whatever. Because the player itself will give no direct instructions to the UI. It's the UI that's listening out for the player to be updated and then adjust itself accordingly. So that's what we're going to be doing here, which means that we also will adjust a little bit of the HP code that we made last time. Before we get into doing any of this UI stuff, let's go back one step and go into our player blueprint here, our player character, and update that HP thing. We don't need the event tick anymore, and this is where we do the any damage. This is just kind of hanging out and not doing that much. So if we have all the nodes that we have here selected, aside from event damage, we don't actually want to select that. We can just right click this and collapse it to a function. It's right here. And that makes a new function for us, and we'll call this subtract HP, and we can give this input a name, and we'll call this amount or something like that. This still does the exact same thing, but now we can call this from other places aside from event damage. Maybe you want to be able to subtract HP from something that isn't actually a damage event in any way, shape or form. Now we can call that as well. And this still does the exact same thing, and it even handles killing the player. But we'll add one important extra thing. And that is, if we scroll down in this tab over here, we can add a event dispatcher to our blueprint. And we'll call this on HP updated. If we go over to the details panel with that selected, we can add a new parameter input. And this will be our new HP. That takes in a variable, just like a function could. And that's going to be our type blueprint structure stats that we made last time. Now, this is an event dispatcher that we ourselves will have made. We did this before with the score updating. Again, if you followed along with that, you probably remember things about this. We're going to do the same thing with the player character here. So anytime we subtract HP, what we do is we just call out our on HP updated before the branch, because the branch just takes care of killing the player if that ends up being necessary. And we need to give in the new HP structure value that is going to get sent through with this event dispatcher. We can actually just get that from the members out struct that we have here. And now this is going to call out this event dispatcher for any object that might be listening out for it, which is going to be our HUD that we have over here. And it's going to get given the new HP value. So that also includes the max HP and the minimum HP in case we need that for any sort of reason. The reason that we're doing it this way is now it's going to be relatively easy to also make a function if we just duplicate this one, calling this set current HP. And we don't need to do any of this mathematics stuff. All that we need to do is give this input the name new current HP. And just pull this directly into this member stat. We will keep the kill player thing here, because if we ever set this to a value that's 0, that might be a good way to just instantly kill the player as well. And we have another function that we'll be able to use to directly set the HP. That will now also call on HP updated. So whether we subtract HP or we directly set the HP, this thing is going to get called either way, and our HUD will respond to it either way. And you could make extra functions for set max HP, set minimum HP, increase maximum HP, decrease maximum HP, all that type of stuff. So let's make one more function here by just duplicating subtract HP again, and we duplicate that, and we'll call this increase HP. And this is just going to do the same thing as what we did before, but instead of doing our current value minus the amount that we're giving in, we're going to do it plus the amount that we're giving in. And then instead of getting the maximum between the lowest allowed value for it and the current value, what we're going to be doing is we'll get the minimum between our new current value and our highest allowed value. So we get the minimum between these. That way, if our current value is still under our max, it's just going to give us our current value. But if our current value would have gone over our max, that way this node outputs just whatever our max value would be. And once again, this just instantly also calls on HP updated. Technically, there's no real good reason for this to also include the kill player, because there's no real scenario where increasing your HP is going to kill the player. But you can definitely see we have this, hey, if this is less than 0, kill the player, in 3 different functions now, which is just a little bit clunky, because if we want to update this in any sort of way in the future, now the same code exists in 3 places. It's not ideal. So we're actually going to remove that from all 3 of these functions, and I'll just cut this out so that I can paste it in a moment. And we'll just run all of that code in response to this event dispatcher getting called instead. So in the event graph, what we can do is in our onBegin play, we have a bunch of event dispatcher related stuff here already. Let's just add one more. We can very easily say, hey, on HP updated, the event dispatcher that we made, just drag that in, and we want to assign something to it. And what we're going to be assigning is check player death. We don't really need to use the new HP value for this necessarily, because we just already have our current HP as a variable that exists here. But we might as well just use the outputs that is getting sent through with the event dispatcher. So we can just pull off of this like I just did, break it, and we get the same outputs that we would get directly from the variable. Just hook in the current to there, and then we don't need to use the variable. We can just use the parameter from this instead. I'll make a little bit of room because this thing is getting a little bit messy otherwise. And we'll probably do a video about organizing this all a little bit better in the future, because as you can see, we're starting to have a lot of stuff that's just kind of hanging out and not doing that much good. But either way, now we have it set up so that whenever we update the HP, it's also just going to check, hey, should we kill the player, yes or no? If in the future at any point we add other functions that also will be able to change our HP in any meaningful way, it's going to still be able to check, hey, does that also mean we kill the player? We don't need to re-copy and paste this bit of code every single time we want to add a new different way to update our HP. One last thing to do is whenever we kill the player, we set our HP back to our max HP. And we did that just by pretty much hard coding that with these variables. But now what we can do is we can just set our current HP with the function we made to our max HP. This way is also going to have that event dispatcher callout. And just like that, we've updated our code for our HP to be a lot more solid and a lot more workable now that other objects need to listen out for it and interact with it. With all of that done, we can go back into our HUD and start working on actually hooking that up to our HP bar. So let's go into the event graph, and on event construct, what we want to do is we want to have a variable that references to the player character that this HUD is displaying. You can just get player character or get player pawn, and that will also get you the player character. Don't get me wrong, that'll work, but it's generally a good thing to also get used to not being able to just take these shortcuts, because sometimes maybe you want to display data about a object or a character that isn't your player character, and then how do you get that reference? Because you can't always rely on having these kind of shortcuts to the specific reference that you want. So instead, we're going to make a variable here that's going to be our player, and that's going to be a BP player character object reference. We'll set that to being exposed, so instance editable in here, and then we can also expose it on spawn. And what that'll do is when we spawn in this widget, it's going to have an input pin for us to give in a value for what this variable will be. I will show that in a moment if we go back to where we make this widget. But now that we have that, we can use this variable to assign on HP updated, the event dispatcher that we just made, and you will see that we have this new HP that we can work with. So whenever our character's HP gets updated, what we need to do is we need to get the progress bar, which automatically gets added as a variable after we added it to our canvas here. So that's kind of nice. And we just set the percentage. We can easily get the percentage by just breaking our new HP and getting our current value and dividing that by our maximum value. And that's going to be a 0 to 1 value on the percentage of HP that we have. And that is everything there is to it. Now this thing is just linked up to our player, at least the player that we give in when we create this widget in the first place. To be clear, it is not actively looking out for a change in the HP variable or anything. It isn't magically linked to this variable. It's just linked up to this event dispatcher. And we've coded our entire blueprint in such a way that the only way for this HP to be updated also will call out this event dispatcher with the new value of it. If we were to in some way update this HP and just set it to a new value manually, without using one of the functions that we created for it, the event dispatcher is being bypassed and it will not update our UI. It's another one of those things where, just like I think in the respawn transform, we set this thing to private because we actually never really want to directly work with this variable. We only want to do stuff where we set it or we get it through functions or events. That way we can add in extra code that will also run alongside of giving this thing a new value. The same thing with this HP. So we can mark this as private so we don't even accidentally access it from any other place. And if we then ever need to get this value, instead of directly accessing this variable, we would make a function here, which would be get HP. And that would simply just add a return node and it returns our HP. You can just drag it in like that, and that's everything there is to it. But that ensures that we only ever update our HP through the functions that we've created for it, instead of directly messing with the variable. Because if you directly mess with the variable, none of this will run in response to it. That said, we have in here somewhere, again, this is why you want to organize your code a little bit better than I have. Turns out I put it in the player controller. We make this widget, and you can see this widget now has this input for the player because we set this player variable as being exposed on spawn. So we need to give in the player whenever we make the HUD. The easiest way for now to accomplish that is to get the controlled pawn, which is just the thing that we're possessing, and we can cast that to our BP player character, because it's always going to be a BP player character in our case. If you're making a game where you potentially have something possessed that is not this, you might need to adjust some code around here, but we're going to keep things relatively simple. So we can just plug that into our player inputs, and that's pretty much all that we need to do there. Except there is one tiny issue. Because we have this thing where we can actually destroy the player. When the player is destroyed, we respawn in a new player and we possess that player instead. So if our control pawn gets destroyed, our HUD widget is going to be listening out for a character that no longer exists. And meanwhile, we are playing as an entirely newly spawned in character that's not being listened out for. So we also need to make sure that whenever this player controller possesses a new pawn, that gets updated in our HUD as well. Luckily, the player controller has a event possessed or possesses, and that's just going to run in response to whenever we possess a new pawn. So in that case, we can just again cast that to our player character, because we're assuming in this case, again, that we're always going to be possessing a player character. That should then run a function or an event here on our HUD, which we are keeping as a variable. We've set that up previously. That should update all of the bindings to event dispatchers to look out for our new player character. So in the HUD, instead of doing this directly in construct, what we will do is we'll put this into a new separate event. Custom events, set new player. First and foremost, that's going to just override our player like this, so we can give in a new value for it. And then it's going to just continue on in doing this bind on HP updated, and going to do this in response to that binding. And this is where Blueprint is kind of really cool, because we can still have this hooked up to construct so that the default one skips over this little setting of the new player and just uses whatever player we gave in to it initially. But we still have a event here that we can now call that does the exact same thing from this point forward, but also just sets the player variable to a new value first. And now that we have made that, we can go back into our player controller and just get our HUD, and we can set new player. Now, even if we get destroyed, it's going to set our new player here to be used in our HUD. And if we want to be really thorough, we can even say, hey, this event that runs in response to this event dispatcher, this is still an event that we just can call, right? We can just say on HP updated event, we can just call this as a node manually as well. The fact that it's bound to an event dispatcher doesn't make it any less of just a normal event as well. So whenever we do that, we can just give it the initial value with get HP to make sure that we also, whenever we possess something new, or maybe we start the game with a non-full HP bar or whatever, it's also just going to forcefully run this at least once, and then after that it's going to run it every time in response to our HP being updated. That's a lot of mumbo jumbo and a lot of talking about event dispatchers and bindings and all that kind of stuff. And this is a really important concept to start trying to wrap your head around, because the two main methods of code being run in, well, any program, but let's focus on games here, is by either calling a function or binding to an event. These events will be called different things in different programming languages. Blueprint calls it an event dispatcher, C++ calls it a delegate, C# calls it an event. But the main thing is that these are the two directions that you can communicate in. You can either have one object tell another object, hey, this is exactly what you need to do. That would be a function call. That also counts for calling these things that we call events in our event graph. These are just functions by all accounts. The same thing as a function. The other way is you have an object that isn't being told directly, hey, run this function. It's an object that's looking out for, hey, a thing happened. The object itself knows I need to run a function in response to that. Learning to understand both the use of function calls, but also of these event dispatchers, is a key part to developing your skills as a programmer and moving away from stuffing everything into event tick, which is what a lot of beginning programmers end up doing. All that out of the way though, we now will have an HP bar existing on our screen, and when we get attacked, it will tick down. And it will tick down again and again until we die, at which point let's actually die in a place where we won't instantly get attacked again. At which point we will respawn in the center and we should have a full HP bar again. Because when our HP bar got filled up, we're doing that through an event that calls out the event dispatcher that our UI is looking for. And even if this character were to be entirely destroyed, it still will just try to keep up with having a new character. So for now, let's just do a debug key on K for kill. And whenever we press that, we will just destroy this actor. And that'll show you that even if I get destroyed, so let's just do this, and then I will destroy myself. I respawn in the middle, and our UI at this point is going to still respond to our newly spawned in actor because of all of the things that we have set up. So we have HP. However, that means that the enemy can kill us, but we can't kill the enemy. I'm going to keep this somewhat normal platformer-like, and we're going to just do the Mario thing of we need to jump on our enemies, and that's what we're going to be doing in the next part. Our character now has HP and a way to die and a way to showcase its HP, but it doesn't really have a way to fight back yet. So we can't like jump onto this guy and kill him like a platformer game oftentimes would have. So let's fix that today. All in all, it's a pretty simple thing to implement for the most part. So we can just go Ctrl-B with this thing selected to find it in our content browser and open it up. What we need to do is we need to have some sort of collider that will recognize when we are being jumped on. So that is to say that it doesn't really care when are we being collided on down here at all. It's just going to be a collider that exists kind of around the head area. And we can just add in a sphere collider to do that and put it, well, around the head area. As easily as that. Now by default this should be enabled with overlap events and just overlap everything dynamic. And then if we go into the event graph with this sphere selected, we can scroll all the way down, and here we will have a on component begin overlap event. This will be an event that is very much like the actor begin overlap, but it will only work in response to something specifically overlapping this sphere component. This actor itself doesn't really have any other overlapping components that can be triggered with this, but maybe some of the child actors that we make of this will have a sword, and the sword will have a collider box to deal damage to the player or something like that. In which case we want to specifically know that, hey, this is our kill sphere. If the player enters this, that means that the enemy is the one being damaged. Any other components that might generate overlap events will not trigger any sort of death to this enemy. In saying that, it probably makes sense to not put this in BP enemy 1, as we are doing this right now, but instead go to our base enemy, because mostly every single enemy we're going to want to be able to jump on to kill. So if we come up here in the top right corner, we can open the parent class of this blueprint, which is going to be our base enemy. In there, we can set up the sphere collision instead. Just put that roughly where the head is going to be. And we can scroll down and on components begin overlap. Here we get some information on the overlap components, the other actor, so the actor that did the overlapping with us, the component of that actor that we were overlapping with, the index of that, whether or not it was from a sweep or and then the sweep result. Don't care too much about those last few ones. The most important thing here is the other actor, because we only really want this to run in response to if that other actor is equal to get player pawn. If for any reason anything is not the player pawn, but still overlapping with this thing, we kind of just want to do nothing. Only the player is allowed to kill this thing. So we add in a branch, and only if this is true do we even do the rest. Now we also will need to know if the player is on its way down. Because if we're jumping up and overlapping with this, generally you wouldn't consider that to be stomping on an enemy, and you probably wouldn't want that to kill this enemy. So we also want this other actor to cast it to our character. And the reason we're not casting it to the player character, which we could do and would kind of function as also executing the same thing that we're doing in this branch, is just to build good habits. We need to get something that exists on the actor class, that being the character movement component's velocity. We don't need to access anything that is specifically added in our player blueprint class. So we don't need to cast to it. If you need to cast, always cast to the most generic tier of your blueprint or class hierarchy that you possibly can. Especially if you can cast to any of the Unreal native classes, the things that Unreal just gives you, because those are C++ classes, which are much less expensive generally to cast to than casting directly to a blueprint for a couple of different reasons that for now don't really matter. But it's a good habit to get into to when you cast, try to say, okay, which class do I need the information from that contains the variables or functions that I need to access, and only cast up to that instead of just casting to exactly the player character in this case. Then, as the player character, we get the character movement component. So if we just scroll all the way down, it'll be in here somewhere, get character movement. And there we can get the velocity from that. It's just below my taskbar here, but it's the yellow one. And here we just want to check, hey, the velocity, are we moving downward? So we can just break this velocity into its x, y, and z components. The x and the y, I don't care about. I don't care about how much I'm moving left or right or forward or backward. I only care about how much I'm moving up or down. And I care about this being less than, or equal to, I suppose, but it's effectively always going to be less than a value of 0. If our velocity in the up and down direction is negative, that means that we're actively going downward, being pulled down by gravity. So let's do this. And if that is the case, this component is being overlapped by the player pawn, and then the player pawn's velocity in the downward direction is less than 0. We can just, for now, destroy this actor. You'd probably want to like drop some coins or something like that. So maybe spawn in a gem. That actually isn't a bad idea. So spawn actor on class. We made like a gem at some point called a pickup, I believe. And the spawn transform for that will just be, well, let's split the structure pin. We'll keep the rotation and the scale just at defaults. And the location for this gem will just be the get actor location for whenever this actor was in the world. And let's also make our character just do an extra little jump, which is separate from the whole jumping system code that we have written for him before. So what we can do is just get our character reference here, and we have this thing called a launch character, which has X, Y override or Z override. We don't really care about the X and the Y. We only want to override the Z. And we can just put that all the way over here as well. And give this Z just some amount of value. You can actually get this from the character movement component if you wanted to. Just get the Z jump velocity. And if we then split the structure pin on this character launch, we can hook up this Z into there, meaning that we're always going to be jumping the exact same amount as a normal jump would be. But because we're not tying into any of the jumping code that we have, we're not really influencing things like the jump counter system that we have set up, or even Unreal's built-in jump counter in any sort of way. So what is it going to do now is it will spawn in a pickup, it will launch our character up, and then destroy this enemy. And it's going to be able to do that for every type of enemy that we made, because we made this in the BP base enemy. We'll come back to this in a moment after we've tested out that it works. But if we go into enemy number 1, we'll see that we still have the sphere component here, and we can just fine tune this a little if we wanted to. I'm going to move this down ever so slightly. And for the most part, that should be fine. Let's run the game and let's try to jump on this guy. And it works. He died. I jumped up a little and he now has become a gem, which I can pick up no problem. If you find your jump to be a little too weak as a response to jumping on a character, we can just get our Z velocity and multiply it by some value. Let's say this will be twice as strong as a normal jump, so we really feel the fact that we're bouncing off of this. Similar to how we maybe needed to tweak the double jump a little bit, it can be useful to just say, okay, you see, there we actually properly feel the fact that we bounced off of it. Maybe that's even a little too much. Maybe we want to go like 1.5. This is the type of thing that you can endlessly keep tweaking and tweaking and tweaking until you feel okay about it. 1.5 seems roughly okay here, and we have our gem. There's a couple of things that we can tweak about this though. Number one is we're always spawning the exact same thing. So maybe we want to promote this to a variable so we can choose on a per enemy basis what they will spawn when they die. That is a possibility. But maybe some enemies we also don't want to launch the character when they die. So are we going to really complicate this with adding a variable here and then adding a branch with a variable here and then maybe adding even more code with a bunch of branches and variables, and it just becomes very messy very quickly. All this, component overlap, all blah blah blah, that works fine for everything. Destroying this actor also works fine for pretty much everything. It's just this in-between little bit here that seems a little... Maybe you want to be able to change this on a per-case basis. So this is where we change this into a function like we did a bunch of times in a bunch of other blueprints before. Now we can say with this spawn actor and this launch character, as well as this launch z jump and the multiplication, select it, we right click this, we collapse this to a function, and we call this on enemy killed response. And you see that it has two input pins here, and one of which is a character object, the other one is the character movement object. So we only really need the character reference. We can just get the movement component from this, from the character reference. So we don't need that to have two separate inputs. So we can say this is our player reference. Now this means this is the default handling of what happens when any enemy dies, which is fine. We can disconnect the on enemy killed response self 3 pin. But every single enemy blueprint that we have now can give its own implementation to this instead. So if we go into, after we compile this, go into BP enemy 1, we click on this override button, we get all of the functions that exist within all of the parent classes. You can see there's a bunch of functions that exist within actor, where we also have a override here for on enemy killed response. So we can make a function for that. Now this specific blueprint can either replace whatever the parent version of this function was, so these couple of nodes here, or just add on to what is already there. The cool thing about that is that this parent blueprint will just call the on enemy killed response, and depending on which actual child blueprint, which actual enemy that it is in the world, it can have wildly different responses. Maybe this one turns into a gem, but maybe a different one, instead of spawning in a gem, we would get rid of this, and it would spawn in a bomb. So after you kill this thing, you need to make sure that you get out of the way super quickly. Maybe you have a slime enemy, a classic RPG type of enemy, and when it dies, instead of spawning in a gem, it spawns in 2 or 3 versions of itself that are a little bit smaller. And so on and so forth. This is where we go back into this inheritance hierarchy. Because we have this blueprint be a child of a different blueprint, the parent can set up frameworks of code that the child blueprint itself can then add or define functionality for. This is no different from our begin play. Begin play is just something that gets added to the framework of the actor class itself by Unreal inside of C++, and then any blueprint that we make can just add on functionality to the already existing begin play function. Exact same thing for this overlap or this event tick. These are things that are made to exist on the actor class. And then everything that is a child of the actor class, which is most of the blueprints that you're going to be making, will be able to add in their own code in response to when those functions are called. So just to show you that, we have all of this code set up on the base enemy for running this on enemy killed response. If in BP enemy 1, I just let it do all that, but also print a string that says, hey, I was killed. And let's make that just red or pink, because why not? Now when I run this, it's going to run that which also prints out, hey, I was killed. It's pretty small on screen right now, but it does do that. If, however, I just duplicate this BP enemy to make a BP enemy 2, and I go into its on enemy killed response, removing this print string, and instead I spawn a particle system at a location, so just get actor location. Do we have any default Niagara systems in here? Fountain lightweight, something like that. It's going to, whenever I kill enemy 2, spawn in this particle system. We'll talk about particle systems a little bit more in the future. And to show you how this works, I'm going to make this also use a slightly different mesh. Just this one probably will do. That's fine. So this one is going to start chasing us because he doesn't have any patrol points. But we can see if I jump on him, he spawns in whatever the base implementation is, which is spawning in that little gem. But he also spawns in that particle system that specifically that class did. You will notice that he didn't say anything about, hey, I'm being killed with a print string, because that is the specific implementation that this guy has, and he prints a string, does not spawn a particle system. If I go back into BP Animate 2, and I also remove this call to parents, that means that now the original version that the BP base enemy class itself, which is this one, has made, will no longer run. That orange node is just running this version of the code. Now that that orange node has been removed, it's going to no longer make me jump up. It's no longer going to spawn in that gem. It's only going to do the new version of what I told it to do, which is spawning in that particle system. However, the other one still does do it, and the gem didn't spawn in there because it was on a slope and the spawning probably just failed. If I do it here, he should spawn in the gem without any trouble. Hello? Oh, I just immediately overlapped with the gem the moment he spawned in. That's funny. Either way, we can now kill enemies, and we technically have two different enemies that are both killable and do their own thing in response to death. We technically have a functioning video game in some ways. We've got enemies, we've got collectibles that spawn when we kill enemies, we've got health. What we don't have is many of our own assets. We are still using these Unreal mannequins. This one isn't even animated. So today, let's get started with actually making our very first character model here that we can then use to make our enemy and make our player. Start texturing, rigging, animating it over the next couple of parts. And for that, we're going to jump right into Blender. I've got a default cube here. We're going to delete the default cube as is tradition, and then we're going to add a new cube in. Why, you might ask? Because I'm a silly little guy. The character that we're going to be making is going to be fairly low poly, and we're going to start by making a relatively generic base mesh. And from there, we can copy that and adjust it, add things to it to start making variations, maybe like a different hairstyle, maybe giving a different little props. But everything is going to be working off of one singular base mesh, all using the same rig as well, so they will all be able to share animations too. We'll do that one step at a time. However, first things first, if we open up our item menu here, we can see that the dimensions for this cube are 2 meters by 2 meters by 2 meters. Well, that's a bit big. And while theoretically there's nothing necessarily super wrong with making something that is just too large in scale and scaling it down inside Unreal Engine, it's good to make things at the size that you're going to be using them at. So in this case, our entire character would be 2 meters by 2 meters by 2 meters. It's a little bit big. I'm going to go for a kind of semi-chibi-ish cartoony style here. So he's probably going to end up being relatively short. I actually think that our character is going to be more in the neighborhood of about 1 meter tall. And then we can scale this down however we like until we get to a pretty decent starting point for the hips. What we're going to do is we're going to start from the hips and then model upward for the body and downward for the legs. And then go back in and adjust a couple of the edges and the loop cuts that we have to maybe slightly round out a few things. But for the most part, things are going to remain relatively blocky. A character is pretty symmetrical for the most part. At least our base mesh is going to be. So is there really going to be much use in me modeling something? I'm just going to do this as an example and having to do the exact same thing over on this side. But hey, if you really pay attention, this is not the exact same thing. There's minor differences between the left and the right, and that's not ideal. So we want this to mirror along the X and the Y axis, and we've done something like that before with the little diamond that we made. If you come up here into Editor Preferences, in the Add-ons tab, you will likely see Auto Mirror. It might not be enabled, you might need to look for it, but it should be packaged in with Blender as you have downloaded it. With that, we can come over into the tabs here on the right. There's going to be a little bit fewer tabs on your Blender, most likely, because I have a bunch of add-ons here that you might not have. And there we can go auto mirror. We want to mirror it in the X direction, following the red line, the left to right line, and just click auto mirror. Now we have added a mirror modifier. If we turn that off, we can see that it has just cut our model in half and duplicated it over to the other side. Now, if I go in and I do something on one side, it automatically does the exact same thing on the other side with the exact same geometry and topology and everything like that. So with all that set up, we can go into well edit mode like I was just a moment ago, and we just press A to select everything, S to scale, Z to lock it into the up and down axis, and then we scale this down until we get about at the size of where our hips are going to start. We're going to fine tune this in a moment a little bit anyway. Then, making sure that we're in face select mode by pressing 3, we select this top face, E to extrude, kind of up to the chest area. So this would be roughly where the lower ribs exist. E to extrude again, up to where the shoulders would be. E to extrude again. This is going to be the length of the shoulder. And then we need to start making the arms, the head, and the legs from this. So let's start with the arms because they're the easiest. We just E to extrude and S to scale this down a little bit. Then we can press numpad 1 to go into front view mode. We still have that face selected. Press G to move, Z to move it only up and down. And then we just move this up a little bit in such a way that this is more or less a straight line. That will create a bit of an armpit shape for us here. At this point, it's good to orbit around a little bit and seeing, well, this is a little too wide for an arm, and it might just generally be a little too wide for the body as a whole. But let's start by just tweaking the arm a bit. We scale an S, look it to the Y, and make this a little bit more just square shaped. Then we E to extrude until we reach about where the elbow would be. And for the elbows, it's important to make a couple of loops really close to each other, because we only can animate this, we can only deform this where there actually is geometry to change. We can't bend in the middle of a face here. We need geometry in order for us to be able to bend those joints. So if we just E to extrude a little bit, E to extrude a little bit, E to extrude a little bit, this now gives us the possibility to start bending this, using it as a elbow joint. We might come back and make this a little bit more elbow-like in a moment as well. But first, we do E to extrude again, all the way for the lower arm. This one, you might want to scale in a little bit as well. And then we're not going to make a super complex hand, because hands are kind of difficult to really deal with. The shape of them is kind of tricky to get right. It's one of the most infamous things that artists always struggle with, is making good hands. And the fingers especially, also for animation, for rigging, they become just kind of tedious and kind of annoying to do. And the thing about hands is, along with the face, there's some of the things that we as humans are most sensitive to being just not right. There's something about hands, if you've ever seen an AI image, it's really quick to jump out at you when hands aren't correct. So if you do a hand and it kind of just isn't that good, you're better off just leaving the hand off if you can. And that's what we're going to do. So we're going to E to extrude again. Then we S to scale this up a little bit. Then we E to extrude again. Scale it up a little bit again. E to extrude. E to extrude. Scale this a little bit down. E to extrude. Scale this down a lot more. And this is just kind of our replacement for having a proper hand. We still have a thing that we can put like a sword into, but it doesn't have fingers, it doesn't have a palm, it doesn't have anything. All that it is just a thing that implies there being a hand there. I know everything that we're doing so far still is really, really blocky. We're going to change and improve that in a moment. But first, I want to make the leg as well. And we're going to make that in a very similar way as well. We E to extrude, and we S to scale, and you might see that this doesn't separate. And if that is the case, you want to come over into your modifier tab and temporarily disable clipping, because that will then allow you to move these apart. The thing with clipping is it will make the left and right side kind of welded together and prevent you from having things like this, where we kind of have just a open hole going right into our model. We'll fix that in a moment. But then, as soon as these two things aren't very close together anymore, you can turn on back clipping, because we're going to want that for the rest of our model. We'll get back to doing the lag in a moment. First, we want to go ahead and fix this hole. And that's going to be relatively easy, because we can just select all these three edges by being in edge select mode, pressing 2 on your keyboard, and selecting multiple edges by just clicking them one at a time while holding shift. And if you press the F key, it just fills it in with a face. And now we've fixed that issue. Then going back into face select mode with 3, we can E to extrude down to where the knees would be roughly. And with the knees, we're going to do the same thing that we did here with the arms and the elbows. We're going to make 1, 2, 3 little extrusions. And this is going to be the knee. And then we just pull down to where the ankle is going to be. And we pull down a little bit more. And these are going to be the feet. Then we select the front of the foot. We E to extrude. We scale this down a little bit. Then you can go into numpad 3 for the side view, because you want this to be aligned with the bottom of the foot, of course. And then E to extrude again. And instead of S to scale, which you still can do if you want to, another thing that we can do is we can go back into edge selecting mode with 2. Just select the top edge of the foot and then press G to allow movement, and G again. This will lock the movement to sliding along the face that this edge exists on, which is a helpful thing to just pull down one of the edges of a face. Then back in face select mode, I'm going to select the tip of our toes, S to scale, lock it to the x-axis and pull it in a little bit. Then G to move, Y to lock it to the Y, and just pull this out a little bit more as well. And these are essentially going to be our feet. Next up would be the head, and we're going to do the head, but the head is, just like the hands, something that if it just looks a little bit off, it's going to be weird. So we want to be careful about that. We select here the kind of shoulder area. We press E to extrude, and S to scale, and then again, go into edge select modes. We select this edge and GG to slide until we get it to being roughly square shaped between the left and right added together, because then we can E to extrude that for the neck. And now we can start making the head. The head is going to be relatively big because, again, the closer we get to normal human proportions, the weirder this low poly look is gonna be. And if we just create a little bit of distance between a semi-realistic looking human and what we're making, we get away with a lot more little mistakes. If you want to make a super realistic human, or even a low poly human that has realistic proportions, if the proportions don't quite match, it's going to start looking weird real quick. You want to make sure that you're outside of the uncanny valley. And you can either do that by being really good at making realistic humans, or making sure that you're not getting too close to a realistic human without actually getting there. And then from the neck, we E to extrude up. This is going to be roughly the neck. And then we E to extrude a bit, S to scale that up. And here it's a good idea to, again, make sure that you are working with something that is roughly square shaped. So we can take this edge and maybe move it out a little bit more. This will be more or less the chin area. Let's E to extrude one more time, and then S to scale that up a little bit in a slightly rounded way. So make sure that this isn't a straight line, it's just sloping up a little bit. Then we E to extrude again, and this is going to be a pretty large extrusion. This is going to mostly be the face area. So this is going to be one plate that's going to function as the face. Then we E to extrude, we S to scale this in a little bit, and that's going to be it for now. This still is probably more blocky than you would like it to be. So let's go back over some of these areas and start adding in a bit more detail. Because even without adding much more topology, We can go into edge select mode, for instance, and select these two edges here, and G to move, Y to lock into the Y-axis, and just create a bit of bulk in the chest. Can do the same thing back here, and that starts creating a bit of a rib cage. For the legs and arms, we're going to want to probably add one more loop in both of its directions, so that we can add a little bit of roundness to that as well. If we just press Ctrl and R, we can add in a full loop cut over our entire model, and we can do that here as well. And this will also immediately add one along the arm if all your topology ends up working out. It also adds something to the head, which is going to be good because we also want to relax some of these angles a little bit in a moment. So let's add one more loop cut here to the arm area. And then what we can do is we can just select, holding down Control and selecting this edge down here. That selects everything in between those in the shortest path. Just move this out a little, create some roundness. Do the same thing back here, G and Y, move this out a little. And we probably could do with selecting all of these faces as well. So we select all of these, and then at the same time, probably select all of these. I'm just going to click them individually for now, and then scale in the Y to just scale these back a little bit as well. And for legs, it might also make sense to just take everything on this bottom loop. So if we are in face select mode and we alt click an edge here, it's going to select the entire loop. And we might want to just scale this down a little bit as well, because generally lower legs aren't as bulky as the upper legs. And it helps separate our legs from our shoes a little bit as well. So that's going to help. And we can do a little bit of a pull out with these edges as well, but in the X direction instead. And that is going to start making our legs just a little bit more rounded. And suddenly they're still low poly, they're still kind of blocky, but they're not Minecrafty anymore, if you kind of get what I mean. And from there, we just kind of keep going. This is going to be the hips area. So our hips probably going to need to be a little bit wider. Can probably pull this out a fair bit and then pull this out a little bit more so that we have a little bit of a slope down. Be a little less than this. This edge as well. We go from there to there. Pull this out to make it a little bit more round. And we can go into even face or vertex rather, select and start pulling out individual vertices if you want to. That's a little tricky because you can make things look a little wonky if you do that too much. So do be careful with that. And for the arm, instead of picking these edges, what I'm going to do is more or less the same results, just a different method. I'm going to do what we did for the legs here, kinda. And that's we're going to select the entire arm's faces on one side. Well, actually I have to do both sides at the same time. And then we just scale this down in the Z. And that also accomplishes the same rounding, but the arms as a whole were just a little bit bulky as is. That said, I kind of feel like they're a little too straight. So we can select this edge loop by, again, going into edge select, holding down Alt while we click on this edge, selects the loop, and just scale up this a little bit. That makes it connect up a little bit more. We need to probably move this down a bit then, to the shoulders, while also creating a bit more bulk around this area. Maybe even scale this in a way where we exclude the Z now. So that is Shift Z after you press S, and bulk this up even more so that we have much more of a fall off between the shoulder to the elbow to the wrist. And that gets us to the shoulders themselves. I'm just going to pull this up a little bit, and that by itself is going to do quite a lot, leaving us with just the face. For the face, what we can do is, once again, start off by just selecting this edge over here, and then shift selecting this edge, then control to over here, and we just scale this in the Y, and that immediately starts rounding that out a little bit. What we can also do here is with edge select any given edge, and with GG to slide this, you can see that we can start also kind of influencing the shape of the head a little bit. In this case, I'm actually not unhappy with it as it is, so I'm going to kind of keep it where we have. What I might do, however, is I might select this upper one all the way around here and just Control B to bevel to add in one more loop into it, just to make it have a little bit of a smoother fall off. At this point, we take a look back at the proportions because we've kind of been winging it. This is a fairly normal human proportion character, and you can see that it does look weird because it's just slightly off in a lot of different places. So we're going to kind of chibify this, which I'm going to do in X-ray mode. So we can just toggle X-ray mode here. I'm back into edit mode, and I like to do this in vertex select mode. So pressing 1 and just box select and move the entire body here down, box select a little bit, move the legs up a little bit, and just make everything a little bit more stubby to begin with. And then the upper body itself needs to come down a fair bit as well, like this. And honestly, maybe everything right there also just comes in a little bit to make it a little bit more narrow. We can turn off X-ray mode every so often to just take a look at our current state of being. That also squished down the hands a little bit. So what I'm going to do is I select just one point on the hands. In this case, we have a really nice central point here. Go up to proportional editing and turn that on. And that's going to allow us to move everything around this vertex that we're moving here with some fall off. And if we scroll with our scroll wheel, we can influence that fall off. So we can kind of just pull this back into being more of the hand shape that we're looking for. If you're looking for a different fall off, we can say, well, actually I want a more spherical fall off. That also will allow us to do this with slightly different types of fall off. And that pretty much gets us back to the hands that we needed. And to really cheapify this, we're going to increase the size of the head by quite a lot. I will select everything aside from the neck itself, and we're going to just scale this up a lot to begin with. Then move it back up as well. And I'm mostly going to want to scale this a lot in the X direction as well to keep it a bit more proportional. And then scale everything up just in general again. And at some point we're going to notice now actually we went a little overboard with this. And I think we're at that point. So we want to scale this down again a little bit. And this seems like a pretty good middle ground. If you turn off X-ray, you get a better look at what everything actually looks like. At which point we can start going through and selecting some edges, sliding them to create a little bit more of a face area here again. And the face is fairly angular at this point. So we'll go into edge or face select mode rather, and scale this in the Y so that we can flatten this out a little bit more. And then we have this loop over here, which is a nice opportunity for us to pull this out to round out the head a bit extra. And at this point, you can start adding in some extra facial features. Like maybe we want to add in some ears. So we add in 2 loop cuts here. Then we can go into face select mode, select these 2 faces, I2 inset them, create some extra geometry for us to work with, and then we can scale this in the Y. That might create something where they kind of go into the model itself, and that's because they're not exactly flat in the Y direction. But for now, the way that we're going to fix that is just to scale this in the X to be 0. That flattens that entirely out. And then just move it more or less back into place. And then we can scale this until we roughly have what the ears are going to look like. Something like this. Then extrude that out. And extrude it out again. And scale it down. You can even go back into face select and inset this again and extrude this in a little bit to create some actual geometry for the ear. Do be warned though, this does come back into the potentiality of something becoming a little bit uncanny. If you start adding in a lot of details to this, it might start being a little off because the proportion for the ears at this point, like this is a little bit on the small side potentially. And you might also not want to add in these ears to your base mesh because different characters might have different ears. So I'm going to Ctrl-Z through that because I don't want to have the ears on our base mesh. I'm also not going to be adding any mouth or eyes or nose to this. We'll add those as a separate extra layer over top of it so that we can do that on a per character basis a little bit more easily. Let's rename our cube our base mesh. Look at how tall he is. He's about 1 meter 73. I want them to be a little bit smaller, so we're going to scale this down until he's about 130. Then I will go into front view mode with numpad 1, and I just want to move up his feet until they're just equal to wherever this red line is, because that is the Z0 height. So now he's actually standing on what is effectively the quote-unquote floor of our Blender scene. And with that, we've made our very first little character block out. Now, he doesn't have textures, he doesn't have a rig, he isn't animated. We're going to be doing that one step at a time over the next handful of videos. But just as a quick little preview of how we can now use this base mesh, we just Shift D, which duplicates it. We can hide the original base mesh up here, so we don't see it anymore. And now we can start editing this one. So this one, maybe we do want to add in some pointy ears, right? So we can start adding in some loop cuts here. And instead of what we did before, maybe what we want to do is just take this and bevel it. That's another way of creating that geometry we needed there. And the upside is that it creates a triangle for us, so we can very easily start creating that kind of pointy ear shape that we wanted. So let's extrude that. So let's scale that up a little bit, move it up, extrude, and then just take this and move it up even more. And we've made a variation. Now, don't go ahead and make too many different variations of this before we get into preparing this thing for rigging and texturing and all that kind of stuff, because you're going to need to redo a bunch of work between different assets here, and you don't want to do that. So next time, we're going to look at making the basic preparations to get this thing textured. So far, all the environment art that we've made in section 1 of this series has just relied on materials that are one solid color. And that is partly because we're doing something that is that kind of super flat, stylized kind of look. But we're doing that flat, stylized kind of look because it allowed me to skip over actual texture creation during the first bits of this series. Today, though, we've made our character, at least base mesh for our character, and we're not going to just give this thing flat colors. Which is to say, we're still going to give this thing mostly flat colors, but it's not going to be just one material that is one color. It's actually going to be working off of a texture. But now that we need to map a texture onto a 3D model, we need to talk about UV unwrapping first. Because if we have an image and a 3D model, how do we decide which pixels of that image to display on which parts of our 3D model? Well, what we do is, more or less, we take our 3D model and we flatten it out like you're trying to cut up an object and put it on a piece of paper. And then wherever we put those cut up pieces of our model on the texture, that's going to be the pixels that are going to be, well, rendered on those bits of the model. To give you a very easy example, if I add in a cube here, and I'll just move that to the side real quick, I can go into my UV editing space up here, and you can see that this is the cube as it is laid out flat. This is hopefully something that you've seen before in school, or otherwise maybe doing like papercraft type of creative projects or whatever, where you have this 2D unpacked version of what a 3D thing can look like. What we have here is this face, is this face, and this face is this face, this face is this face, this face is this face, this one is this one, and then we have this one is this one. That is all well and good, but in order for that to work, we need to tell our model that it is allowed to cut right here. Because if this face is this one, and this one is this one, and this one is this one, that means that both of these two edges are actually this one edge. And that's because this one edge has been marked as being allowed to be cut. We can actually look at this in this view if we are in UV editing, and we have this little icon up here, the UV sync selection turned on. And we have, in this case, face select mode on. We can click on any of these faces, and it doesn't actually map 100% face-to-face the way that I explained it before, but the whole holds true. I can click on any of these faces, and it will show me which one of the faces in the 2D view corresponds to it. So once again, which face is the middle one here? It's this one. You can see that if I select this face, it's this one up here, and then this one is this one up here. They both share this edge over here, and if I select this one edge, it highlights both of these, because both of these are this edge. This edge is just a seam. And that is what UV unwrapping is about, is deciding where do the seams go on my model that are going to be the places where it gets cut, so that we project this onto our texture with minimal stretching. And we're going to be doing that with our little basic mesh here. To prepare for that though, we're going to first give this thing a material. So go into the materials, we give this a new material, and let's just call this UV for the UV material. And Blender has a built-in texture that you can give into a material that shows you kind of a useful reference on how stretched any given part of your model can be. So if we go into the shading tab here, we can edit our material that we just made. We can see up here, we're editing the UV material, as we called it. And pressing Shift and A, we can just search for image texture. So image texture is going to give us a node where we can connect up the color to the base color. And that will be, well, the color that our texture is going to be. We don't have a texture in here yet though, so we need to create a new texture. We'll call this UV grid. And the generated type, we can choose this to be a UV grid. There's also a color grid, which shows you different colors as well as it being a grid, so you can use that as well if you prefer. I'm going to stick with UV grid and just say new image. And now you can see that we have a bunch of weirdness going on here, because we've got the texture displaying here, and we've got the texture super stretched out over here. And we've got a bunch of gray where we don't see anything, which actually is just a mega super stretched out version of that texture for the rest of the body. And then the head is just more stretched out stuff. Going over into the UV editing now, if we select everything, we can see this is how our model is getting unpacked. Just a bunch of messy stuff that is even clipping over itself and overlaying itself. Not ideal. If we want to be able to see this texture being mapped onto our model while we're working on it in edit mode, we can, I need to just move over my viewport a little bit, but we can come up into here as long as we're in viewport shading mode. And we can change this to displaying the texture of the material that we're using on this model. And now it will actually display this as that texture. And from here, we need to start making decisions on where does this logically make sense to start putting down seam. One of the places that might make sense is around the hips. So let's start by selecting one edge over here, and then holding down Control, we can click on a different edge here, and it will take the shortest path between those edges and select everything. The shortest path selection, however, if you come down here into our little folding menu, we can change this to not selecting those edges, but tagging them as a seam. And this will color them red. And that shows you, hey, you've tagged these as allowing to be a seam that we're going to use to cut up our model to get our UVs for our texture. You also can just click on any edge, press the U key, and mark it as a seam. That does the same thing. It's just the control version of this, just makes everything a little bit faster. We're still working with the mirror modifier, by the way, so it's also getting applied on this side, which is very, very helpful. In a moment, we'll want to start applying that mirror modifier because we don't want the same texture on the left and the right here necessarily, but we'll get to that when we get to that. So let's do the same thing around the shoulder here, so that we can separate the leg from the body and the shoulder from the body. And then we're also going to separate the head from the body. Usually, don't try that at home, by the way, separating the head from the body. Very unhealthy thing to do. But now that we've done all that, we can select everything, press U, and now we can start unwrapping this. We can unwrap this in a number of different ways. Usually I like to go with angle-based. You can say, well, I really need minimum amount of stretching here, or conformal, which I've never actually put into practice. So I'm going to stick with angle-based. And now we can see we have much more of actual texturing going on, but there still is a lot of stretching. Because this entire thing over here, the entire leg, is still just one big blob if we select this in our viewport here, we can actually press the L key and it will select the entire UV island. We can see that this entire thing is the texture area for the lag. It has even got some stuff that's still overlapping with itself. It's just a giant mess. As a general rule of thumb, you want to limit the amount of UV islands, as they're called, which are entirely separated bits of UV, while also having every UV island be visually distinct as to what it is. Can we tell that this is the lag? Even a little bit? Not really, so we probably need to start adding in some more cuts. Cuts don't need to always entirely separate whole parts of the model. In this case, we've separated a couple of parts entirely out together from each other. But sometimes just adding in a little bit of a seam, like right here, for instance, around this foot area, can be enough. This didn't separate anything out from the rest of this island. It's still going to be one island, but it's going to now be a little bit more capable of stretching around that seam. As you'll be able to see, if I select this island, somewhere in there it now has a hole because it is able to separate these faces along these edges. A thing that might help is doing something like cutting up the back of this leg and then cutting down the middle of this foot as well. Let's unwrap that again, and we're starting to see that we're getting rid of more and more of the stretching. There still is a lot of stretching going on. So for the purpose of what we're doing here, I do think what I will end up doing in reality is just select this edge, press the period key on my numpad to center my view around it. And I'm going to separate the foot from the leg, because that's going to help us make things a little bit easier. I also want to mark the crotch area here as a seam, because it hadn't been up until now. And with that, we'll see that now the leg is very much separated from the foot. This is now the leg, this is the foot. The leg still has stretching though. How come? Well, because the leg now has become a cylinder. And in order for a cylinder to be able to be flattened out, it still does need to have a line at which it is cut. If you take a piece of paper and you roll it up into a cylinder shape, and you tape both of the edges of that piece of paper together, you can't flatten it out anymore. You can only flatten out that cylinder if those edges aren't stuck together. And in this case, we've got a cylinder where all the edges are stuck together, which means that we're going to need to find a place that is not going to be too visually obvious, where we can make that seam to flatten out that cylinder. It's a very low poly cylinder, but it's essentially a cylinder. The inside of the leg is a pretty good place to do that with. And if we now unwrap this again, now we'll finally be able to see that this is our unwrapped leg, and it's not majorly stretched. There's a little bit of stretching going on. And if this guide is a little confusing to you with, well, this seems a little longer and not properly square, and it's not a very good grid, that is correct. You can also come up into here somewhere. I think it is in the guides here. And you can say, I want to show the UV stretch. And this shows you every single face and how stretched it is, from very blue, being very non-stretched, to very red, which is, oh my god, please fix this, and everything in the heat map in between. So you can see there's a bit of stretching still going on with these, and that can just be fine, honestly. If you really wanted to, you could maybe here in the back of the knee add in one more seam and see if that makes a major difference, but it really doesn't. It didn't even use it in this case. So you can see what it does when you choose minimal stretch instead. It unwraps it differently and it's a little bit less stretched. Now, for this foot, how are we going to do this? Let's start by saying that this is going to be an area that we want to work from. So let's mark these two areas as seams. And then really what we want to do is we want to just start imagining that we want to be able to flip up this area to align itself with this area. Can we do that right now? Well, not really, because it's attached to this and this area. So we need to select both of these and mark this as a seam. Now we can flip up this area to align it. Can we flip up this area to align it with this? Well, also not really, right? Well, yeah, we can. It will take these two areas with it, the sides of the foot, but that's fine. Because these can also fold down without too much trouble because they're already cut up and marked as seams all the way around. The only real issue here is the back of the foot. Because we can't fold out the back of the foot without making one more cut on either side of it. After we've done that, we can cut out and fold out the back of the foot to be aligned with the bottom of the foot. The sides of the foot can fold down without taking anything else with it. Then that whole area can fold up to align with this. Then that can fold up to align with this. And there will just be a little bit of stretching between these, but that is fine. So after we've done that, let's unwrap with minimal stretch. And we see there is a little bit of stretching still going on here with these feet, which may be solved if we mark these two as seams as well. Let's see, minimum stretch. That improves things a lot. So it had a lot of trouble here folding down this entire area as one giant piece. But now that we have said, hey, this island, allow this little cut at both of these sides, which you can see, that's why that cut exists. It can do it without as much stretching now, which is fantastic. And our leg also is pretty much non-stretched. Our body is fairly good to go, honestly. We don't really need to do too much work on the body, it seems like. That's already just pretty much good. And that gets us to the arm. For the arm, we're going to go to the hand as well and just mark this as a seam and do something similar to what we did on the leg and just take the underside of it, create a seam, and that should allow us to, without any trouble, unwrap the arm as well, leaving us only with the hand. We select the hand, we can see, we want to do that with face select, and then L to select everything that's linked. We can see there's a lot of stretching going on here as well. And that's because we're pretty much trying to get a sphere to unwrap itself. Not ideal. So while we could just add in some seams here at the bottom and add in a line to unwrap it, you don't always need to add in extra islands, and you don't want to necessarily. So what we're going to do is we're just going to add in a little incision into here instead. And that'll just allow this thing to fold open a little bit more without it actually being cut up all that much. And we'll be able to see that that does a pretty good improvement. Maybe we'll add in a little incision here at the top as well. And at that point, this is pretty much good enough. This is what our hand looks like in our UV view now. And that leaves us with the head. The head itself is pretty good as is as well. We don't really need to do too much with it, but oftentimes it is a useful thing to go up to the top of your character's head and just make a seam to the back of the head. That allows it to kind of open up and get rid of a little bit of stretching that exists around the head. And sometimes you then make that go over to the ear or something like that. In this case, I kind of feel like what we have here might be good enough. So let's do minimum stretch. And it just unwraps it the exact same way. We can do it angle-based as well. And it's still pretty much good. So while this isn't the perfect UV unwrap by any stretch of the imagination, it's what we're going to go for right now. And with that, we have our entire 3D model. Every single one of our polygons has a place in our texture space now. At this point, it becomes about packing these in a efficient way, because we have a lot of empty space, wasting resolution for the texture that we're going to be creating. Blender has a built-in UV pack islands function, and that tries to pack in islands in the most efficient way that it can, while also keeping the relative size of these squares the same between everywhere on the model. Because we could just go in here and say, well, we want this little thing for the hand and scale it up super big, and then take this area over here for the arm and scale it down so much. And now our arm has almost no resolution at all for detailing, and our hand has way more than it likely needs. So the automatic packing just kind of keeps everything at the same scale. Of course, however, if you know that certain parts of your mesh are going to not need as much resolution, and some might do with a little bit more resolution, you can manually choose to start scaling things up and down and kind of adjust them all over the place a little bit to give more or less space to certain areas. But now that we've done that, we still only have half of our thing projected here, because if we select this half of the face, that's these polygons. But these polygons don't have their own space in our texture. They share this area. If I were to texture something on the left or the right here, it would mirror it along as well. This is the moment where we go into our modifier tab, we go into our mirror modifier and apply it. We did that after doing the basic unwrapping, because now the seams are also mirrored to the left and to the right. We'll need to redo the unwrap, and we'll see that some of the parts are going to be a little bit stretchy now again. So we need to do a little bit more work. And the little bit more work that we're going to do is mostly just going to be adding in a seam around the back here, and maybe making this seam go all the way up to the back of the head. That might actually be enough to what we need to actually do for this. So let's see. We need to select everything to project it, and honestly, I think that kind of does the trick. There's a little bit of stretching going on here around the face area still, but that's honestly kind of fine. Now, at this point, I personally don't use Blender to properly paint in any textures. I would go over to Substance Painter for this, where I would also generally have a high poly version of a model and a low poly version, and it would have a lot more steps in the entire process. And maybe sometime down the line we'll do something where we sculpt a character with high poly and then we retopologize it and we go through that process as well. I would take that into Substance Painter. But since I'm doing this series here with the idea that you don't need to have any paid software at all, everything that we use is going to be entirely free, no paid plugins, no extra stuff needed aside from a PC that can just handle this stuff, we're going to stay in Blender for this one. And we're going to make a actual proper material for this. So make our first material here. We'll remove our previous material that we had there. And we'll create a base character material. Let's go back into our shading tab here. And there we're going to do the same thing that we did before. With Shift and A, we add in an image texture, and we'll make a new texture for this. So we'll keep this as just color black, and this is going to be the resolution of our texture. 1024 by 1024 is probably enough for what we're doing here. But for higher detail characters, sometimes you might want to go for double this, so that's 2048, or even quadruple this for a 4K texture, which would be 4090. Let's take in the middle with a 2K texture, which is 2048 by 2048. The reason that it's not just 1000, 2000, and 4000 is because these are all powers of 2. So they're easily divisible by 2 all the way down until they get to a resolution of, well, 2 pixels again. You've got 2, 4, 16, 32, 64, 128, 265, 512, 1024, 2048, 4096, and then 8192 off the top of my head, and that's something about 16,000, way more than you're going to be using for game textures. Let's give it a name as well, base character texture. We can give it an alpha or not, that's just the transparency. We don't really need this to have an alpha, and that is going to be our new image. Of course, I immediately mess up and make it a UV grid instead of just being black. We want to make this a blank texture, so let's try that again. Base character texture, and try that again. And now we have that black. If we go into texture painting mode now, we get to see our texture here on the left-hand side, and we can switch between the different textures that exist in our project with this drop-down menu, and we get a view of our model over on the right-hand side here. We have colors to choose from, so let's just make this a generic pinkish like skin color. like beige pink kind of skin color, and we can start painting this in. And as we do this, when I let go, you can see that it's starting to actually paint in the texture on the left-hand side from whatever I'm painting in on the model itself. So that's kind of nice. You also very much can paint this like you would in a Photoshop or whatever other drawing program you use within this view as well. And here also you will see, when I let go, we see it appear on the model. We have a fill tool, which is fantastic because it lets us fill the entire thing with one standard color. And he's kind of naked right now. At this point, we could start drawing in some textures as like clothes and that kind of stuff. And that might not be a bad idea. So let's give him like a blue shirt, and we can draw that in just like this. It's a bit messy to do it with painting like this, but that's entirely a thing that we could 100% do. But we want this to be symmetrical as well, so we want to make sure that in our viewport over here we have symmetry turned on, and that will paint this on the left and the right side at the same time as well. Quite helpful too. And you'll notice that I'm accidentally painting onto his face as well. So how do we prevent that? Well, we prevent that by masking out certain bits of the geometry that we want to be working on or not working on. It's a handful of methods of doing this. The best way that I like doing it is to just go in here and say, hey, we're going to be hiding this. And then it doesn't exist anymore within texture paint mode. So we can't paint onto it. Everything still is entirely flat colors though, which not great necessarily. We want to add in a little bit more detail to this. First and foremost, let's give him shoes though. And those shoes are just going to be black for now because I already used brown. Well, maybe give him white shoes. He's got like Nikes or something like that. Because black is just not a pleasant color to use in textures a lot of the time. He's starting to look a little bit like a Lego character because he's still only got really solid colors here. Of course, we can just start drawing in like a little design, like give him a little dragon. This is going to be super bad because, again, I'm very bad at drawing, but we can start like drawing in like, dragon. Give him some flames, and we've got a dragon print on our shirt. we can do that. If you're better at drawing than me, you can do that. But maybe we just want to add in a bit of like detailing, a little spackling of a different shade of blue onto the shirt, just to have something going on. And we can do that by just selecting our new shade of blue and, well, start drawing it in, right? Maybe not quite. If we go into our brush, or our texture rather, we can make a new texture, and we'll call this texture noise 1. And with that texture being selected, we can come over here into our texture tab. And that allows us to import textures to use as brushes, which is really quite nice. Or just use a variety of pre-configured and adjustable noise patterns. So we can use this cloud pattern, for instance. And now if I start drawing with this, you can see it's using a black to whatever color I have, gradient of that texture as my brush. But we don't want it to be black, we just want it to kind of use that as the shape of our brush. So that's where texture mask comes in. We can use that same texture instead in our texture mask, and then if we use this, it just paints with that texture without the black. It just uses that as the alpha, the transparency for whatever color we are using. So if we just take that and we do this a little bit, we are essentially kind of like tie-dyeing our texture. And that we can do if we go back into our texture painting view here. We can just go into any image that we have. In this case, that's going to be our base texture. Just image, and then we can save it as, and it'll save it as a PNG for us. So save this image, open up Unreal Engine, and here we can just make a quick new folder. Actually, let's do this in the player folder, and then just make a folder for assets. We can just drag in our texture right here. And if, just as an example, we go File, Port, FBX, drag that in as well. Just import this as a static mesh for now, that's all good. It will take the texture with it as well from Blender into the FBX, and then from the FBX into Unreal, assuming the file paths all work out and that kind of stuff. So we can just immediately have that ready to go. That said though, it did also take in the cube with it because I forgot that we had that cube. So let's remove that from Blender and then re-export it real quick. Unreal crashed somehow in the background, so I'm going to re-import this super quick. And we should be able to see it takes in the texture. It even makes a material here. Unreal automatically makes materials off of just basic FBX data. So it has this FBX legacy surface material, where it just takes in some textures and some values and that kind of stuff from FBX materials. So we can straight up just have our guy in engine. He's not animated, he's not even a skeletal mesh, but that's our guy inside Unreal now. But he's not quite our guy yet, because we, well, need to customize him. Next time we're going to make some customizations to his model to actually make him our player character, and then we need to retexture him as well. We have our base mesh, which is technically sort of textures. We're going to redo some of the texturing as we have an actual player character in a future video. But for now, before we make any variations, it's probably good to make sure that this base mesh has a, well, base rig. Any copies that we're going to be making off of this base mesh should already know how they relate to the skeleton that we're going to be giving it. So we don't have to reparent every single bit of the model that we're going to be working with going forward every single time we make a variation. So it is rigging time, at least the Blender side of things. We're going to go into the Unreal side of things a little bit later. As you can see, I moved into front view mode with numpad 1 because it's a good starting point to work off of. Then, making sure we're in object mode, I'm going to Shift A and add a armature single bone. That will add our first bone for our skeleton, and it's piercing through our character. However, first things first, we want to be able to see these bones no matter what. Even if they're inside of our character, we want to be able to see them. So with that bone selected, we can come over into its data properties, which is just shaped like a little dude. And in there, ignore all the Rigify and Unreal script stuff, you won't have that. You will still have a viewport display category though. And there we can say that we always want to show this in front. So now no matter what direction we're looking at this from, it will show us, well, the bone in front of our character. It's going to be helpful because a lot of these bones are going to exist inside of the model. Then we can tab over into edit mode and we can start editing this bone around. This first bone is going to be the root bone. So this is where everything is going to be springing off of from. At some point we might also go into Unreal and make animations with root motion, and that involves animating this bone to actually move our character itself within the world, rather than just playing it as an animation. For now though, just select the upper bit of the bone, G to move, Z to move it down, and just move it all the way down, make it small, that's fine. You can click on it and F2 to rename it. It's good to name this root, and then clicking back up onto the top little ball that it has there, you can just extrude this out, Z, to make sure that you extrude it only up into the Z-axis, and we've got our second bone. These are, however, connected, and we don't want these to be connected. So we can press Alt and P, and then we can disconnect the bone. We don't want to clear the parent, we still want these two things to be linked to each other, we just don't want them to be physically connected, necessarily. So we disconnect the bone, and now we can move one bone away from the other, but they're still connected to each other with this little dotted line. Anyway, G to move, Z to move it up, and we're going to be moving this up to the hip area. Make this a relatively small bone, and we're going to select it and rename this spine.001, because now if we extrude up again, this will automatically be called spine 002. And like this, we're going to just make a couple of spine bones. Usually we make one that is essentially the hip, then one going from the hip to the rib cage, and then the rib cage itself isn't super flexible, so you don't really need a lot of bones within that. It still is good to make one bone that goes from the shoulder bottom to the shoulder top, then one for the neck, and one for the head. With all those in place, do try to make sure that they're all not rotated as well. That's going to be quite important going forward into Unreal. But now that they're all in place, let's just look if they're actually properly within the model. And it looks like none of them are sticking out in weird angles or whatever. So we can go back into front view mode and we can start working on the arms. We need to pick a bone in the spine that these are going to come off of. And when we extrude out of a bone, it will extrude out of this top area of the bone. So when we want to extrude out of this bone, it's going to come out of this little point. If we extrude out of this point, it's going to be attached to this bone instead. So what we want to do is the shoulders should probably be connected to this thing over here. So that's going to be this bone. We extrude, and this time we're going to lock it to the x-axis, just pull it out a little bit. And once again, we just disconnect the bone because we're going to be moving this over in the x, move it over down into the z, so that it starts at the shoulder and goes about up to the elbow area that we made. And we extrude it again into the x, all the way up to the wrist. We extrude it again through to the hand. Now these are going to be named weirdly. These are spine 9, 10, and 11. Not ideal. So let's rename these arm.l, or .r actually, this is the right arm. I'm recording a lot of videos today, okay? .001. And then we just name this one .002. You can just name this one hand.r, or otherwise arm.r.003. Same thing, really. And then from there, what I often like to do is extrude one more out of this one, disconnect the bone, rotate, in this case in the Y, by minus 90 degrees, so that it's upright, and then move this one back into the hand, because we can call this weapon.r. If any of our characters have weapons, we will now be able to individually animate the weapon inside of the hand without having to contort our hands into weird, unnatural positions. There's another upside of not having actual fingers in your hand, because you can cheat a little bit with rotating or moving something like a sword handle within this clump of flesh that we call a hand. After we've done that, it is good to go up and check if nothing is sticking out. If it is, it's good to go up into top view mode with numpad 7 and just take these points and move them, but lock them with Shift Z, so they're locked in the X and Y axis, and you can kind of move them into place a little bit better if they're sticking out in any weird sort of ways. And then, time to move on to the legs. So go back into front view mode. We want to come off of the hip bone here and extrude this out as well. This one I'm actually going to give a good name right away, leg.r.001. Disconnect the bone, move it down, move it over, rotate in the Y by 90 degrees, move it, locking it with Shift Y into the plane that we're looking at right now, all the way through there, then down to the knee, extrude, down to the ankle, and then look at it from the side view, extrude in the Y to about the middle of the foot. I want to move it down a little bit, and then extrude again, look that to the Y, to the tippy toe of the foot. This way we'll be able to have him stand on his toes, because just one foot bone generally isn't enough for that. And that's pretty much the entire, well, right side of our character's skeleton. So now we need to do the same thing on the left side. But because we modeled this thing entirely symmetrically, isn't there a way that we can just copy over everything on the right to the left? Well, that's why we named everything with those .r's in the name. Arm.r, leg.r, because if we just select everything and press F3 and look for symmetrize, then we'll just take everything with an R in it and flip it over and automatically rename it with an L in those places. So we have our symmetrical little area now. At which point, it is going to be time to attach our model to this skeleton. Almost. We need to go through in edit mode and real quick take our weapon bones and our root bone, select all of those, go into the bone properties and say that they are not deform bones. Because these aren't going to be directly deforming the mesh, and as we're parenting this to the skeleton, we're going to have it automatically guess how it should be parenting that. And if that doesn't make sense yet, it'll do in a moment, hopefully. But it will do that with everything that is considered a deform bone. And we don't want to directly parent anything from this mesh onto these bones. So we just disable deform on them, and that'll save us a little bit of trouble in a moment. And with that, it is as easy as just selecting our mesh, holding Shift and selecting our bones while in object mode. Control P, that's going to allow us to parent, and we can armature deform with automatic weights. This is going to parent our mesh to our armature, and it's automatically going to, in our mesh, in our data properties, make a whole bunch of vertex groups with the same names as the bones that we had. And this is just the weight for every single point in our mesh on how much it should move along with whenever one of these bones moves. And we can do that in pose mode. So if I go into pose mode, I get any of these bones. You can see that I can start rotating this and everything will rotate with it. And it's good to just kind of go through and see if everything kind of moves with these bones as you would expect it to move. Since all this is fairly low poly, the chances of anything majorly messing up with any of this weighting is pretty small. Once again, comes back to why we made those little extra loops around the elbows, because those are now used to actually deform as an elbow. And maybe we want to kind of slow down on the amount of arm deformation when we move this hand. But you can see that this also... Oh, this was actually still marked as deform. So when you select multiple bones, it only changes the deform setting of the last one. So we're going to need to clean that up as well. Actually, it's not that big of a deal because I want to show you how to clean up these weights anyway. Going back into object mode and selecting the mesh, we can then go into weight painting mode. And in weight painting mode, when we have one of these vertex groups selected, you can see a heat map of how these vertices are weighted toward any specific group that we have. So black is no weights at all, meaning that if we move the bone with this name, this vertex won't move at all. Red means we had in spine like 6 somewhere. Oh, we had a spine 8 bone here. Let's get rid of that. We don't want that. So we can just delete that bone. And then move this one back into place real quick. You can also delete this vertex group. Either way, as I was saying, in weight painting mode, spine 6, you can see that this head is colored entirely red. So every single vertex, every point on this 3D model that is colored red will move 100% with any movement that this bone is going to make. These points down here are also going to move a little bit, but they don't have 100% influence from that bone. And that allows us to make animations that have no weird tearing between parts of the limbs where different bones are and all that kind of stuff, because they kind of smoothly go in from 100% being driven by one bone to being a little bit driven by that bone, but also still by a different bone. And generally, you should be aiming for a vertex within your 3D model to have all of its weights to the different bones add up to a total of 100%. So it might be 50% weighted toward this bone, and 20% weighted towards this bone, and 30 towards this bone. But if it's only 20, 20, and 20, that means a total only 60% weight. That would mean that even if every bone in the entire mesh moves, it's going to stay at its default position with a power or a weight of 40%. And that would create glitchiness and unwanted behavior. If you go over 100%, if you move every single bone in the character, the vertex will move away too much. And it will kind of separate itself from the main body and create weird pulled out sections of your model as well. So you want every single vertex to add up to at least nearly 100%. Doesn't need to be exact. If it's like 95 or 105, for the most part, that's fine. But that's a good rule of thumb. Either way, we can see that this arm has a lot of influence going all the way down to this area and then all the way down to this area. And that's just more than we want it to be. So we can go into our paint settings here and we can make sure that we're in paint mode and then set our weight to 0. And we can start just painting over the vertices that we want to change. And you might not see anything happen at first. And that's because you're not painting in the same way that you're painting a texture. You're painting a texture, you're doing that on the faces of your model. You're doing that on the actual polygons. What we're doing here is we're painting on the points, on the vertices. So if we select everything here, we can go into... If we select vertex mode here, you can actually see the points that I will be clicking on. And it'll be a little bit more sensitive. It's not always intuitive, because it seems like, oh, actually I want to set this one to 0. No, this one already is 0. It's just that this one isn't 0, and it's interpolating between this value and the actual 0 value that we have here along this face. You also can paint on the faces, as you can see here. I find that to be even less intuitive, because a lot of times you can just like click and drag around and nothing actually happens as a result. So I find painting this in actual vertex mode, especially with lower poly characters, is really helpful because you can see the actual points that you want to be clicking on. And with that, we're going to just kind of decrease the amount of influence that a lot of these points have. And we might need to go in and then give that influence back to other bones. And we'll see if that ends up being the case in a moment or not. But this is kind of the main idea. And I might be overdoing it a little bit at this point. If I go back now into pose mode and I move this arm, you can see that now it probably doesn't move nearly enough anymore because it doesn't move this at all. And that means that we're clipping through the chest. And if we go the other way, we're kind of clipping through. Well, not really clipping through, but we're making weird dents in our back. That said, we're never going to probably be this far back, but still, we went a little overboard there. So, to smooth that out, we go back into weight paint mode, and we could start painting them back in with a weight of 1 or anything in between. But this is where the blur tool can come in. This can take the current weights that you have and just kind of smear them out without adding too much in terms of total weight. It just kind of increases the area of influence while also smoothing out the interpolation between those areas. Now, we still have the issue where these things are accidentally parented, and this is a lot easier to solve. Because if you have bones that need to not have any weighting in a certain area, in this case, pretty much anywhere, you can just select those vertices. In this case, again, I don't want this to weight anything, so I just select my entire model. Go to the vertex group for that bone. In this case, that would be the hand. And just remove them. And then you can go to the other one. In this case, that would be the weapon, and just remove them. We also have a weapon R, just remove it. And as easily as that, it has now removed those from our weight painting. So they still are things that then in engine we can start adding in weapons to and that kind of stuff. And with that, we have our base mesh. Well, I wouldn't call it rigged because we're going to actually make a animatable control rig for it in Unreal Engine later. But we have it parented to a armature. So as we've done that, we can rename this armature just something simple like base character armature. And here's the kicker. We can keep everything for this base character, just Shift-D it, and now both of these models are both parented to this armature. And that is only duplicating the mesh. So you have the mesh, just Shift-D that. It creates a second copy of the mesh that is still within the armature. So we can call this player mesh. If we hide the original base mesh now, we have our player mesh. So we can start doing stuff with this. And that stuff can be whatever we want, really. So maybe we can give him some JRPG PS1 character hairdo or something like that now, because we have our player mesh. So we go into edit mode and we just select some verts. We turn on X-ray and select all these verts up here. We can Shift D to duplicate. That creates a duplication of it. We can scale it up a little bit and then press F3 for the search menu and then separate by selection. That's going to make that a separate mesh. Call that player hair for now. And the reason that that is nice is because if we now go into our weight paints, we can see that it already has all of the weights. And if we check it at spline 6, all the weights here are already tied to the head. Everything that we're going to be doing from here is just going to follow the head as it is. Let's try to do, I don't know, something. Making characters, turns out, is just a lot of work. And I would say, have at it. Have some fun. Make your player character from this point. And next time, we're going to import this into the engine and properly rig it up, ready for animation. Between now and that video, I will get my own character refigured out and have actual textures for him made so that we don't waste any more time on me fine-tuning this character and doing stuff with it. But that's kind of the basic idea. And if we want to make a other new character, we just go back to our base character armature, copy it over, and start working off of that again. One final tip that I realized I probably should share as I'm fixing up my own character. A thing that can be helpful is just kind of putting your character into an awkward pose, and then with that pose active, go into object mode and into weight paint mode after selecting your character, and try to figure out things from this point. Because now we can see I'm trying to work on my player mesh here and how these things are being influenced by the legs. So going down to my legs, I can kind of paint this out, and I'm using blur, so I want to paint this at a weight of 0. And then in real time see how things are affected by that. So that really does help quite a lot. I probably do want to blur some of this out a little. It does become hard to sometimes click on the correct points when you do this, because points might start clipping through themselves and other pieces of your model. So it's not always a perfect way of getting things done, but it still can be relatively helpful. And then after you're done with that, you can select your armature again, pose mode, and select everything with A, and with F3, clear transforms, and all transforms so that you go back to your basic T-pose. And now the video is really over. Between the end of the last video, where we started on rigging our character and adding some more details, I've added some eyes, which are just circles that I kind of stuck onto his face and then parented to the skeleton as well, and some eyebrows, which do the same. And I drew in some very basic textures. They're not particularly good, especially back here, they're a little squiggly. But we've ended up with a character that is a in-between version of a we have Cloud Strife and Link at home. With that, I select everything, and then we can export that as we've done before. Export it to FBX. I'm going to only be exporting our selected objects so that I don't export our basic character, which also exists within this project. And then everything in here we can kind of keep the same. We are not going to be exporting animations because the animations we're going to do entirely within Unreal. Today we're building the control rig that we're going to use inside Unreal Engine to animate this character with. The armature, it can be useful to say, hey, add some leaf bones. What that'll do is at the end of every single one of these bones, it'll add one extra bone. Because Unreal Engine won't understand the concept of the beginning and the end of a bone unless it has that extra leaf bone. Unreal Engine will just know, okay, this bone exists at this location and we'll be able to rotate around or move around. But in Unreal Engine, the bones won't have a endpoint. That is something specifically Blender does to make it easier for you to work with. However, sometimes for rigging purposes, it can be nice to have the endpoints of those bones. So Blender lets you add leaf bones to kind of replicate the idea of having start points and endpoints to your bones. We're going to just export that, override what we already had, and then just drag that into Unreal. This will now try to import as a skeletal mesh because it now is, well, a skeletal mesh. We've given it a skeleton, things are parented to that skeleton, and if we import this, we will see it indeed is a skeletal mesh now. We'll make a physics asset with it and a skeleton and all that type of good stuff. Imports a material and our new texture as well, right along with it. And as before, Unreal kind of smooths out your normals when you import models into it, which might be what you want or might not be what you want. So let me just get rid of these two pop-ups over here. If you want the more blocky, low poly style, what we can do is we can come up into the assets details here. We can look for normal. And we can say, don't recompute normal in the build settings, at which point we'll go to LOD 0, apply those changes, and then it will be the more blocky style that we made before. I personally quite like that, so we're going to go with that for now. We can drag this into the world, and we've got our little dude existing in Unreal Engine with all the Unreal lighting on the very, very low poly look that we gave him. So how do we animate this guy? Well, to animate him, we need to have a control rig first. We can technically animate him by just moving the bones as they are, but that's bothersome and annoying to do. You can make a control rig by right-clicking and going into animation and finding control rig somewhere in here, or just click on the skeletal mesh you want to make a control rig for, right-click, and then go to create, and we can create a control rig. You can also make a modular control rig if you have your skeletons set up in a way where they just kind of match with the modules that either you have created or Unreal Engine provides you with. It's a very easy drag and drop saying, okay, the spine goes from here to here, this is the head, these are the arms, these are legs, and you're kind of done really quickly with that. I've got a video showcasing the basic idea there, but we're going to go for a proper custom-made control rig here, so we'll make one of those and open up that asset that we just made. Get a new blueprint-like interface, and what this is going to do is if we go into our rig hierarchy, we can see all of the bones in our character. You can see that it has this spine 6 end and this weapon end, and those are the leaf bones that we talked about. If we didn't have leaf bones, it wouldn't have these end bones, and it would just kind of stop at the bottom of this bone, which again can be a little bit annoying. For the rigging, we really have a couple of different components that we want to take a look at. Number one would be we want to have the spine, going from the hips all the way up to the neck. Then we've got the arms and the legs, which we will do with inverse kinematics. We'll add a little bit of a tweak control to the toes as well. And then we have the head, which we can either do with just being part of the spine, or something that might be a little bit more interesting, is we can give this a target to aim at. One thing at a time though. Let's get started with the spine because it's the easiest. We go just select spine number 1 and shift click on spine 5. And it will just select every single one of those bones. It shows, if you're using a recent version of Unreal, what the up vector, which is the blue line, the right vector, which is the red line, and the forward vector of your selected bones are. That's going to be useful in a moment when we need to choose which directions are considered up and right or forward for things like the inverse kinematics. For now, you can ignore those safely. We have the spine 1 through 5 selected. So all we do is we just drag that into our little event graph here and we say, hey, I want to get this as an item array. And that just gets you a node, which gives you an array that contains spine 1 through 5 in that order. The order is quite important here. With those still selected, we can also right-click those, and we can add some new elements to them. And we'll add new controls. This is going to just copy over the hierarchy of the bones that we had and make new controls. If we zoom out, we can actually see them. We'll make them smaller in a moment, don't worry. With the same names, just with underscore control being appended after them. And the reason that this is nice is we can do the same thing here. Select everything, drag them in, and create an item array. And it creates an item array going from control 1 all the way through to control 5. We'll use those in a moment, but first, this is kind of not workable because they're all huge and overlapping. So again, making sure all our controls are selected. we can come over here into the details panel. And there we have the transform of the control. We're going to largely be leaving that alone for now, but we also have got a separate control for the shape. And that is just the visualization of the control that we're going to be working with and the way that it looks. So if we lock this in the XYZ axis so that it is proportional, we can just drag this down and you can see all these control points are starting to shrink until they kind of make a little bit more sense. And you can see that they actually are distributed along all of these different bones. Opening up the shape properties, we can also set what type of shape we want these to be. There's a lot of built-in shapes that we can go with. Generally for a spine, you go with something like a circle, and I like to do this as a thick circle, and it now shows them as thick circles, but they're upright, and you probably want these to be tilted a little bit so that you really feel like, okay, these are around the bone that I'm going to be controlling with these. That's where we can go into the rotator for our shape transform and just say, well, rotate it by about 90 degrees. And now nothing about the control itself has actually changed. The control hasn't gotten smaller. The control hasn't rotated. All the control transforms themselves are still the default 0, 0, 0. It's just the visualization that we're going to be working with is now more in line with what we would expect it to be. You can even go through one by one. I'm going to set my camera speed a little lower. If I just come down here, we can set the speed to a little lower. So that's a bit easier to move around. And now we just go one by one and we increase the size of these little circles so that they don't clip through the body as much. It is good to also make sure that you actually do have the proportional editing turned on if you want them to be exact circles. If you don't care about that, you can just kind of eyeball it. But it's nice if they're exact circles, just visually. And we make this into a circle as well. Might as well just make this a little bigger too. And now we've got these controls all spaced out over the spine. How do we tell these controls to control these bones now? For a forward kinematic chain, which is a chain where if we rotate one bone, so let's go into Blender to show off what I mean with that, into pose mode. If we rotate this one bone, every bone that is attached to it will rotate with it. In this case, it'll also take the legs with it. We'll worry about that in a moment inside Unreal. But let's take this one bone above. If we rotate this, everything that is attached above it in the hierarchy will rotate with it, right? Because it's, well, parented to it. That makes a lot of sense. This is what forward kinematics is. It is adjusting the position or rotation of one bone, and then it's sending forward up the chains that transform to everything that needs to change as well. Inverse kinematics would be the other way around. Inverse kinematics would be changing this bone and making everything below it change its position and rotation to match whatever it needs to do to reach that end bone position. That sounds very complex, but you don't need to do all the math for that yourself. It's built into Unreal. But pretty much all that we need to do is we need to get the controls that we've got here and just map them to each one of these bones. So when I rotate this control, you can see it already rotates all of the other controls with it as well, because they are parented to each other, just like the bones are. If you ever change the transform of any of these controls, by the way, and you just compile, they snap back to their default position. So you can test out how your rigging works without worrying about messing up the default position fairly easily. Control rig has just a FK chain node, and that takes a array of bones, which is this item array that we have over here, and an array of controls, and just maps them one-to-one. It assumes that, okay, index number 0 is going to be controlled by index number 0 all the way through the entirety of the array. And if you compile that and we use this, we can see that indeed it does work like that. So now this bone controls, well, everything, because everything comes off of the hip bone. This control controls what that bone will do, and so on and so forth. I do now notice that the belt doesn't really work all that well. I might fix that in the future. That's just some weight painting that isn't cooperating. But just like that, we have our basic spine deformation working. Not a problem. Next up, let's do the head, because the head is the next easiest thing to do. We're going to do that with an aim node. And to do that, we need something for it to, well, aim at. We're going to go into spine number 6 here. And again, just make a new control. And that new control is going to be huge again. So we scale down the scale for it. And we need to position this into its new default position. That's going to be just straight ahead from where our character is looking right now. And if we want to apply this transform, so the location that we give this, when we have this in the position that we want it to be, as its default, usually you will be able to right-click on this, or if your menu is kind of messed up like mine, you can even right-click on it in the viewport, and then set initial transform from current. I am not entirely sure why it's not letting me do that right now. Might be an issue specifically with Unreal 5.7. I'm recording these videos on 5.7. My daily use is 5.6, so something might be a little iffy here. Luckily, you can still do that manually by just going into your transforms, current, shift right-clicking your location, going to initial, shift left-clicking that location, and then compile. And you will see that it sticks there because the initial transform is going to be its default position. And then from there, if we move this and we compile, it snaps back to the default position. Again, this right-click option should just automatically do that for you, but if it is grayed out, you can just manually copy them over if need be. With that, we need to aim our head bone toward this control. And for that, we can just use a aim node. It's really quite simple. We tell it which bone we're going to be aiming with, which will be our spine 6. So just select it, and you can use this arrow icon to fill in that field. And then we can give in our target. Our target is going to be our spine control 6. We'll rename it in a moment. And there we can just get control, and we get the transform from that control. We only really need the translation from it. So we give that into the target. You can also give in a direction for the target if you have another way of calculating the direction, but we're going to go with a location. And it just snaps his neck. It's not ideal. And that's because of this axis. This is the axis that we're going to use to align our aim with. So let's disconnect this real quick and go back to selecting our spine 6. We want to aim the blue line toward this little ball. And the blue line is the Z. The red line is the X. And the green line is the Y direction. So we want to aim the Z direction to go toward our control. Right now, it's trying to aim the X, so it's trying to aim this line at this control. That's why it's snapping its neck. As you can see, if we do this, it indeed is aiming the red line at that. We don't want that. So we change this to Z1 and X and Y0. And if you compile that, it's now going to mess that up. It's also going to take in a secondary axis, which is going to be the up and down axis that we're working with. You oftentimes can just kind of zero this out, and that just gets rid of it as a factor altogether. Doing that, though, can give you this warning. So alternatively, you can just figure out what the actual value is you want here. And if we're using the Z-axis as our forward, as our main axis, we need to figure out what the up and down axis along this bone will be, which is this green line. So that corresponds to the Y. You can just set this to Y equals 1, and that should fix that, no problem. You can just see if everything still works as you would expect it to, and it does. So we've got a look at target now. Sweet. We want to move on to the arms, and we're going to be doing the arms with inverse kinematics. For inverse kinematics, we need 2 controls. One where the hand is going to be, and one where the elbow is going to point. Because what we're going to do is we're going to be moving the hand into the place where we want, well, the hand to be. And then the arm bones are going to automatically rotate in such a way that it's going to connect the shoulder to the hand in the position that it is. But for that, it needs to know where the elbow joint is going to point. Is the elbow going to be pointing upward or downward or rather flat? So we go into the arm, and we pick wherever our elbow is, and then we pick wherever our hand is. And for both of those, we add in a new element, and we'll add in a control, just like we have done in the past. We scale those down before we do anything else, because these are rather large. And it will probably make them as children of each other. So the arm will be the parent to the hand. You don't necessarily want that. So right click on the hand and just click unparent. You can also do that with Shift P. That makes them just separate from each other. We're going to take the elbow joint and just kind of pull it back. I'm also going to make both of them even a little bit smaller than they are right now. And once again, usually you would just set initial from current transform. Don't know why that's not working. So we're going to just take this location and put it in there. And that's everything we need to set up our first basic inverse kinematics. So drag off of our little chain that we have here in the event graph and then just type basic IK. I'm going to stick with just the basic IK node for now. Here we give an item A, which is the start of our chain. So that's going to be our shoulder to elbow bone, arm number 1. Then we give it the end of our chain. That's not the hand in this case. It's the wrist. Because the hand isn't the end of the chain, the hand is going to be the controlling object. The length from item A to item B can be effectively anything. Right now it's just 2 bones. It could be 10 bones. It's going to figure out that chain more or less no matter how many bones are in it. Let's give in arm number 2 for item B. And then the effector item will be the item that is the hand, essentially. Or the foot, or the extremity of that limb. So we'll give in the hand. And then we need to give in the effector. The effector is going to be the controller that's going to drive our IK to what position we ideally should be at. It's going to be our hand controller that we have here. So we just drag that in, we get the controller, and we just give in the entire effector here. If we compile this, it's likely going to freak out a little bit. Don't worry about that, that is normal. We need to give in the primary and secondary axis and the pole vector. The pole vector is where the elbow should be pointing. So let's start with the pole vector. And we get in our arm IK control. Again, just get the controller. For this, we only need the location. We don't really care about the rotation on this one. And we connect that up into the pole vector. By default, the basic IK will ask for a direction, but we're not going to be working with a direction. Much like our aim constraint, we want to use a location here instead, because we're going to be pointing at a specific location for that controller. If we do that, you can see that it's now pointing away from it, and that still is because we have to set up these axes. We need to tell it this is the forward direction that our bones are kind of like flowing into, and what is the up or the right direction. By default, the primary axis is set to the X, but if we select any of these bones, so arm number 1 here, for instance, and we real quick just disconnect the basic IK, so we have the basic shape here, we can see that the arms are flowing in the green line's direction. That's not the X, the green line is the Y. So we change this from X to Y, and we connect this back up. And we can see it still is a little weirded out, because the secondary axis is the axis that should be pointing toward our pole vector. That's going to have to be our blue line. Let's see, by default, that's set to green. Why? So let's set that back to 0, and then to Z1 instead. These might still not be the correct values, because as you might notice, our bones are flowing that way, but our green line is going that way. So our bones are actually going into the Y negative direction, and these blue lines are going that way. Our pole vector is in that direction. So it actually should be Z negative 1 here as well. Let's just check if it still messes up. It does. You can see how it twists everything around, because it's now trying to match up that blue line toward the pole vector, but the blue line is just flipping over 100%. We don't really want that. So the blue line should be Z negative 1, meaning that the direction that should be pointing at the pole vector is the opposite of our default Z direction. And now you can see that immediately solved all that problem. Y negative 1 also technically better, because it is actually going in this direction and not in that direction. But now, with all that, if I move this controller, you'll be able to see it moves the arm. And if the arm is a little bit bent, and I move this controller up, the elbow starts pointing toward there. In other words, we've just set up our first inverse kinematic limb. we've got an arm that works based on position rather than just rotating individual bones. We've actually done some proper control ring stuff now. We can just take these two controls, select them both, and we can mirror them as well. Give in a string that identifies these as being right. So in this case, that would just be the capital R. And we can replace their name with a capital L to get the left version of them. We can mirror on any axis. In this case, the left to right axis being the X is what we're going to be mirroring across. And we can flip the Z axis if we wanted to. In this case, we don't want that. We want the Z axis to be aiming in the same direction for both. So we don't have to do anything weird with the IK setup being different. That creates two entirely new controls, which we need to scale down. So let's select both and scale them down. And you can see that they are in the respective positions. You can see that it did flip the Z-axis. Again, I don't think it matters for these controls, so let's not worry about it too much. And as that, we just copy over the basic IK node that we have here and give in the left arm. So left arm 1 in item A, left arm 2 in item B, the hand in the effector item. Then we get our hand control for the left as a control, give that in as the effector, and then we get the arm control as a control, just get the translation from it into the pull vector and compile. It does twist up things a little bit because these things are 180 degrees flipped. So you probably didn't want to flip those. That's easy enough to fix though. We can just get our initial rotation here and just copy it over from this one, and that should line them up perfectly fine in theory. Make sure that you're on initial, not on current, and then when we compile, it now has the exact same rotation between both of those controls. So we can test this out, and it immediately works just fine. But we can't really see the hands right now. So let's select both of these controllers and select a shape for them, a sphere thick. That way we'll have these spheres that we can kind of see through. And the neat thing about these IK controls is if I rotate the controller, it's going to rotate the hand because we set the hand as the effector item. So the hand is just going to be copying over the rotation from the controller. And that way we can super easily, well, bend this arm into shape and then put our hand in the rotation that it needs to be. And for the legs, it's kind of just more of the same. Go into the legs, at the knee, and at the foot. We make controls for those. New elements, new control. Make sure that these are not parented in any way. Get both of them and just make them considerably smaller. Because again, we don't need them to be that humongously big. We move the knee one a little bit over so that this is going to be the thing that the knee will be aiming at. Usually, again, you would right click and set initial from transform. No ID. White keeps being a bitch about that, but we just copy it over from current to initial in here. It's the exact same thing, just a couple more clicks. And then we basic IK. So our right leg is going to be bone number 1. Right leg 2 is going to be bone number 2. And then right leg 3 is going to be our effector item. The effector will be right leg 3. We'll give these proper names in a moment because this is starting to get a little confusing otherwise. And we're kind of going to need to adjust the axis here probably for the bones. So this is likely going to twist up here in a moment. But before we do that, let's just connect everything up. First, we get this control because it's going to be the pull vector. Translation goes into the pull vector and see how twisted up this is going to get pretty badly. It's a good practice to, again, look at which axis you need to pick. Just select the bone that we're working with, and in this case, we're working still with a negative Y because the green line is going away from the flow of our bones. So we need to take the Y, but in the opposite direction. So that is correct. And then in this case, we do want the pull vector to straight up point in the same direction that this blue line is. So instead of Z negative 1, we're going to go Z just positive 1. And that should then not twist up anymore, but still work as our inverse kinematics. And the pull vector also works fine. Perfectly fine. Click on both of these. We just mirror them from the right side to the left side. And this time, let's try to see what happens if we flip none of the axes, because that might be a little bit better. It still ended up flipping them, I don't know. I end up just manually adjusting these. And oftentimes I don't even properly use the mirror function, if I'm being honest with you. I just make new controls manually anyway. For the pull vector, it especially doesn't matter what the rotation is, because we're not even using the rotation for this one. But we might need to adjust this thing here, because of the rotation that it uses. But let's just drag in the control for both of the left leg things. 3 is going to be the effector, 2 is going to be the pull vector, and then we just say left leg 1 to left leg 2, affecting left leg 3. And this is likely going to... It didn't actually twist up. Seems all right. That's great. The flipping of the z-axis did actually do its job there, apparently. We do a sphere thick, so that we can properly see the ankles. And now there is a little bit of twisting up here. And to fix up this thing, we can just see, okay, how is this thing actually rotated? Is it rotated in this axis? It doesn't seem like it. Rotated in this axis definitely doesn't seem like it either. Let's compare real quick. It's messed up in this axis. Usually rotating it back around 180 degrees is what we want. And at that point, we just, again, go into current, paste it into initial, and that should fix that up. No problem now. And we've got leg IK as well. The weight painting is a little weird with the legs because the belt is very stretchy. So I didn't do a great job with the weight painting. But because the legs are now stuck into the location of these controls, you'll be able to see that if I move this spine, it's actually bending the knees as a result. Again, the weight painting could be a little bit better than it is. That said, you very likely want the arm controls to rotate with the upper body. If I rotate the upper body, you probably don't want the arms to just kind of like be stuck into place. That's a little bit weird if that happens. And this is where we can start parenting controls to other controls. So all of these arm-related controls, we probably want those to be parented to this spine controller. That's spine control 4. So we just select everything to do with the hands and the arms, which is all these 4, and just drag and drop them into spine control number 4. And if we compile that, we can now see if I move or rotate the spine, it rotates all of the inverse kinematic stuff along with it, so it properly rotates along now. Helps quite a lot. With all this, there is a lot of just things floating around, and it becomes a little annoying to keep track of everything. Often, what we end up doing is we color code left and right different things, and then a different color for the middle as well. So what I'm going to do here is the right side of all the controls are going to be blue, and it's good to just pick some colors for yourself to be consistent with along all of your different rigs that you make. But this way, it'll be easy while we're animating to see, hey, this control, does this rotate one leg or the other leg or whatever is going on here, right? And the other side will make something that is distinctly very different from blue. So I'm going to go this like green color for the other side, and then everything down the middle will just stay red. You can select multiple controls at the same time, by the way, and just adjust the color for all of them at once. And down here you have your most recently used colors as well in a palette, so you can just click on those and reuse them. And with that, we've got a control rig for our character ready to go. We can just pull this into our level, and it will start by making a sequencer that has that control rig, and we can start animating with it. So put this into some location, probably turn off snapping while you're animating, and put this into a location, and we can start posing our character in whatever way we want. One last thing that I almost forgot to do is we still don't have any control over our toes. So our toes are going to be super easy to do. We just get our leg 4 bones for both of them, and then add a new control. These controls are going to be parented to the respective leg IK controllers. So that is these two. It's the number 3 ones. So lag 3 is going to be parented to lag number 4, and lag number 4 here as well. That didn't make a lot of sense, but you know what I mean, hopefully. Scale down the shape for them, because again, it just adds in way too large shapes by default for no good reason. And we're going to add in these as just little circles, rotate them a little bit in the X so that they line up. And for these, all that these really need to do is we need to parent the bone to the control directly. So we can just look up a parent constraint where we can give in the child, and that's going to be the bone in this case. So that's leg number 4. And we can say this is going to have the parent give it an item. You can just pick these directly from down here. So this will be the right leg 4. I parented these the wrong way around. Give me a moment. Reparenting these can be a little bit tricky sometimes, by the way. So don't just go dragging them around because that can mess things up. You want to unparent them first with Shift and P, and then you want to properly reparent them by just dragging and dropping them. That is okay. And then we can choose this as the control that controls this toe. Now we've got separate controls for this toe, so we can more easily do something like pull this leg up a little, rotate it down a little, and then rotate the toe back up slightly so that he's tiptoeing. And of course, do give it the proper blue color for the side that we're working with. And then the other side, we just copy this over again. And instead of leg 4 on the right, it's going to be leg number 4 on the left and control number 4 on the left as well. And give that the appropriate green color. And we can now rotate this toe as well. One final thing that is going to be useful in the future is being able to use root motion. And we've made a root bone here, but with Control Rig, you straight up just get an extra root bone that you can influence. So we didn't really need this extra root bone here. We're just used to making that one, but you don't need to because you have a direct reference to like the player's transform directly. Just add in a new element to that as well. We can make a new control. For this one, I personally like to use a triangle, make it a little bit smaller, of course, and then point that triangle around until one of its points, well, points in the direction that your character is facing. So you have a good distinction on, hey, this is forward for the character. And root motion controls, I generally end up making white. But that's, again, up to your personal preferences. You can make it pink if you prefer. And then everything we've made so far, make sure everything is collapsed. You don't want to just select everything like this. Because if we're going to drag and drop this onto our root, it's going to destroy the hierarchy of parenting that we already have. We only want the topmost controls that aren't parented to anything at the moment to be parented to our root controller. Otherwise, again, everything will break. But now we've got one controller that will move our entire rig back and forth. If we then, at the very start, the order for this is important, but at the very start of our forward solve here, what we do is we do another one of those parent constraints, and we will just parent our player, the very root of our player, to that root controller. So again, here in parents, 0, item, root controller. If we do this at the end, it's going to start introducing drifts and weirdness. If you do this at the start, it shouldn't be a problem. And now we can animate this, and it will serve as being able to be used as root motion within the engine if we have any animation montages with like an attack or a dash. We've gone over using root motion before. Now we have a controller that we can actually animate to drive root motion, which we're going to need to do because one of the animations that we need to remake is going to be our dash, and our dash relies on root motion. So we need that root motion controller to be able to work with. Let's save that and go back. We'll be able to see that instantly our control rig in our level here has updated as well. We're not going to go in and do any animation right now because this video has been long enough as it is just setting up our control rig. Next time we're going to be diving in and doing some basic animation to make an idle and maybe like a walk cycle animation. We have made this very interesting looking character, and we've made a control rig for him last time around. This time we're going to get started with making some basic animations. This is by no means going to be a full animation course because I, frankly, not a great animator. I'm just going to show you the kind of basics of working with the control rig that we've made, maybe introduce a handful of basic animation concepts, and mostly just focus on the technical aspects of how you set up the workflow to make these animations in engine. That means that we're not going to go through and make every animation here that we're going to need one by one in the video, because that video would be 3 hours long. I'm going to show you a couple of animations that we're going to walk through one step at a time, give you some basic tips to get going, and then between this video and the next one, I'll have made all the animations that we need to move forward from that point on. So how do we make animations? I like to be organized about this stuff. So let's make a new folder, call this animations, and there we have a split between the level sequences, the actual animation timelines that we have, and the animation sequences, which are going to be the assets that we work with in our code. These I also generally like to split into level sequences and anim sequences. And you also might want to make animation montages out of them, but we'll get to that when we get to that. For now, let's go into level sequences and just make, by right-clicking here, go in, level sequence. Name those something like ls for level sequence, character, idle. If we open up this level sequence, we'll get a empty level sequence here with the sequencer. We've worked a little bit with the sequencer before to animate in-world items to move from one position to another position. This is going to be a sequence in which we animate a character and then take that animation data and generate a animation asset out of it. Often it'll be useful to just have a level that is dedicated to having your characters in it, where you can animate them, so you don't have them hanging around in like your main levels in some weird place. You can put them anywhere, but I like just having a separate animation level for this. The default just example template map kind of works well for that in this case, so we're going to be animating it within here. Assuming you have your control rig character already dragged into the scene or just a skeletal mesh, you can just get that from your outliner and drag it into your sequencer, and we can start animating him. But we don't have the control rig yet. Why is that? Well, that is because we need to add it as a channel. We can just add it as a channel, control rig, and here we can add the basic FK control rig, which is just your bone hierarchy. You can move them around, you can rotate them, just like we did before in Blender. But we have made a control rig, so let's add that, and now we can start animating with it. You will notice that it immediately automatically also switches over to the animation mode workspace. So we'll have stuff like some tweening tools, some constraint tools. We don't really need the place actors tab at the moment, so I'm just going to kind of put that in there. We've got an animation outliner, so we have a overview of all of our controls, which still are badly named. I probably should rename those. We've got an animation details panel, and if we go into window and we search for layer, we also can get our animation layers, which is a useful thing to have as well. We can animate these things in layers on top of each other so that the keyframes don't start getting in the way of each other too much. It can be good to animate the bigger motions in one layer and then add in a little bit more personality into a separate layer. Let's get started, shall we? We have our entire control rig, and all the controls that we have for it have their own keyframes. As a rule, when you start off, you just add a keyframe for the entire stack of everything at frame number 0. That way you have a base to work off of. I personally always have auto keying on, so that when I change a value, it just automatically makes a new keyframe for it. That's a personal preference. If you don't like that, you can keep auto keying off, but I like having it on. And from there, we just start posing him. Let's start with a idle animation. So the idle animation is just going to be him having his arms kind of down and then rotating the hands down as well. Maybe having the arm a little bit forward as well. And then this arm also down and over. Maybe not that much down. And this one can be pulled back a little bit. We can also rotate this hand down a little bit. And you can see how I move around quite a lot while doing this. I'm going to set the speed of my camera to a little bit lower value. And move back and forth between the moving of things and the rotation of things. And that's why it's good to get used to the shortcuts of W for movement and E for the rotation gizmo. And maybe we rotate the hips a little bit in as well, so that he's kind of facing forward, and then the whole spine just slightly adds some more rotation on each step the way through. And this control doesn't do that much, to be honest, because the head is aiming at here. So we can aim the head at the different direction, so it really feels like he's standing forward a bit more. And then this elbow can start pointing a little bit more up, so it feels a bit more active. Again, you can see that my weight painting is kind of falling apart here because it is not that good. And then maybe a little bit bent through the knees. And sometimes it can help to kind of put your body in the position that you are looking for. Maybe even take pictures of yourself in the pose that you're thinking about, and then just kind of try to replicate that picture of the pose that you want. This is the reason that a lot of artists, but also animators, have those little wooden human puppets so that they can pose the puppets in the way that they want and have a reference point to look at while they're working. I, at the moment, don't have one of those, so I just kind of have to wing it as we go. But this foot can be a little bit flared open. This foot also flared open, but a bit more forward. And then the whole body can lean a little more forward as well, maybe. And then have him look slightly down. And that can work as a halfway decent idle pose. Now he's interpolating from that pose to the T-pose between these frames. So we don't really want that. Let's collapse the entire character rig here. And what we'll do is we'll remove our first little keyframe there. And just move this to be our default position. And add a new keyframe, again at frame 0. So it fills in everything that we haven't animated yet. From there, let's go to frame number 30, because we're animating at a 30 FPS frame rate, and just move this guy around a little. Make him bend through his knees a little. It's oftentimes good to also slightly move the chest to kind of get a feeling that he's breathing, right? And you can see, even if we just scrub back and forth between this already is a halfway decent idle animation now. It's not great, but an idle animation also doesn't need to be super great. You can just slightly maybe move the arm. Not too much, but it's doing something there. Obviously, the idle animation needs to loop. So if we collapse the entire thing, we can get the entire animation collapsed down to one keyframe. And at 60 frames, just put the beginning pose there again. Then pull down the end of our animation to, well, also 60 frames. And now we will see that we have it loop to the same pose. If you want the preview to also loop, by the way, because right now it just plays it once, and that's kind of everything there is to it. This little arrow here is the looping state. So we can set it to no looping, loop playback range, or that's the only two things that we have. So with that, it now will loop, and it will have a little bit of a stutter at the end when it resets back to frame number 0. So it's not a super good representation of how it's going to look in-game necessarily. But this will be our idle animation. And it's a little, again, a little scuffed with a lot of the weight painting. It's also what you get with this super low poly type of style to a certain extent, but that's going to be pretty decent. Now, I do think that the head could do with a little bit more bobbing. So maybe the head bobs down a little bit as well as we do this. Maybe it looks a little bit more down like this. I can just kind of experiment with what that all looks like. Hey, maybe we even want to just bend the spine forward a little as we go through the animation. See what that does. Now it feels like he's breathing a little, right? And for an idle animation, it being such a simple loop, just going between two poses, it's a bit basic, don't get me wrong, but it's honestly kind of just fine to do that. So let's stick with this for now, because I'm not going to be spending 2 hours on a single animation here. Once we're happy with it, we can right-click our character rig in our sequence here, and right-click it. We can then create a linked animation sequence from this. We can also just bake it to an animation sequence, but the reason for this being done in Engine being so nice is because we can easily make these linked animation sequences. That means that if we come back at a later date to adjust and improve this animation, which it's going to need a bit of improvement, it's not great, but when we adjust this level sequence and we save it, the linked animation sequence will instantly be updated as well. So our gameplay animations will right away reflect anything we change in this level sequence, as opposed to baking it into an animation sequence, which will just make a copy of what we have right now and just more or less export that as its own asset. Same way that it would work in Blender. If we animate something in Blender and we export that, then if we want to make a change, we need to go back into Blender, make the change, re-export it, re-import it, and it just is a bit of a hassle. So creating a linked animation sequence here is going to try to, by default, put it in the same folder as the skeletal mesh itself. So I go down here to animation sequences, and we'll call this just character underscore idle, because it's going to be the character's idle animation. Let's export that. Always good to just double check that you've saved everything before closing down your level sequence. And now in the animation sequences, we have our, well, animation sequence. Let's take a look at that in here, and we've got our little idle sequence. Not going to be winning any animation awards with this, but it is a model that is indeed moving. So it is an animation. Let's make a walk cycle. We start the same way. We make a level sequence, ls underscore character walk. Then we open it up. We go into our outliner, make sure that we have this thing in our world. We have it selected. We can just drag it in, add a new channel for the control rig. And here we might start using those animation layers a little bit. A walk cycle is a lot more complicated than just an idle animation that oscillates back between two poses. And as I said, I'm not a professional animator by any stretch of the imagination. This is not necessarily an in-depth animation tutorial on how to do animation, because I am in no way qualified to be telling you how to do that, beyond the basics and some technical stuff. But the basic idea of a walk cycle is going between these poses. You have a pose where one foot makes contact with the ground, while the other foot is in the process of lifting off. Then it plants down, while the other one goes up. Then the back foot will pass by the planted down foot. It will start to reach forward, all while the planted down foot is getting ready to push itself away from the ground in a moment. And then the foot will get back to contact and this ready to push off kind of pose where we started, but just with the other feet. And you do the exact same thing, just with the legs swapped around. And then eventually you end up back in this contact pose and you've made a walk cycle. And there is a bunch of personality that you can start adding in here in the way that they move, in the amount that they might move up and down during the cycle, whether they take large or small steps, whether they do it small, whether they do it quick or slow, whether they spend a long time in the lifting up phase and then a very short time stomping down, whether it is very smooth, how much the upper body rotates along or against that movement. This is where you can start adding a bunch of personality to the entire thing. We're going to keep it fairly generic though. So let's start with just posing him in a really neutral position again, similar to how we were in our idle, with just both of our arms being beside the body and rotate it down a little like this. And then from there, we're going to start with the contact pose for this foot. So this foot will be moved forward a little bit and then be rotated up. Make sure that it doesn't lift off or clip through the floor too much. And you can see here we have a bit of a problem where it doesn't quite reach the floor because his legs are fairly stubby. Now, one thing that we can do to help a little bit with that is just to move the spine as a whole forward, which makes sense with a walk, so that's fine. Then we move this one back a little, and as an unintended side effect of how the IK works when we have no stretching and how this control works, it kind of just puts us into the proper position of having that foot with the toe kind of being bent, just by default, more or less, but we can do a little bit of work with it. Might also not be a bad idea to just have this a little bit more down, not by much, because we need some room to actually animate this going up and down, but having this a little bit more down, also not a terrible idea. Gives us a bit more room to do stuff like this. That might be a little more down than we really want it to be though. And you can start seeing this whole thing requires a lot of tweaking and just generally takes a long time to get correct. Then the arms will be in the opposite direction, swinging to where the legs are. So this leg is forward. That means that the arm for this side is going to be backward. And this leg is backward. And that means that this arm is going to be forward. That's just a thing that humans do to balance as they walk. So we want to replicate that. With that as our basic starting pose, we add a keyframe for everything that we have in here, and then I like to just move down 15 frames at a time and first get the poses down. We can worry about timing a little bit later, but the poses being down is the most important part here. So let's do the next pose. The next pose is the down pose, where this foot gets properly planted down. This foot starts actually leaving the ground, and our spine generally just goes a little bit more down as we have made ground contact. Our arms also go a little bit more into their respective swinging directions as a result. So let's do that. And it might make sense to also make our character just lean forward ever so slightly as we do that. And you can see how that moves from one pose into the next. Then we have the pass-by pose. I'm going to go to frame number 30. And here it might start being relevant that we have a bunch of things that don't have keyframes. If I now start animating spine number 4, it's going to interpolate its movement between the start and frame 30 without having a keyframe in the pose at frame 15. That might be desirable, that might not be desirable. It's just something to be aware of. You can just add a full keyframe onto everything in this pose, and then you can be sure that everything will be the way it is in this, and start interpolating just from this pose. Nothing weird will happen. But it can also be nice to limit the amount of keyframes that you're using and have certain parts of the body interpolate more smoothly over a longer period of time. In this case, I'm just going to delete the thing that I made there to begin with. So, the pass-by pose. There, the character will go back up with their spine a little, and honestly will also rotate this back to being a little bit more straight up in general. And this foot will start moving back. The thing you have to keep in mind is what we're doing here is we're animating a walk cycle in place. Of course, this is going to, in the end, when we put this into the game, gonna play when we're moving through the world. So what's happening here is not that this foot is moving. It's this foot should stay on contact with the ground if we match our movement speed with our animation speed. And it should look like our character is just moving forward over the leg. This is one of those things where animating it in place is really quite tricky. Without actually seeing it move, it feels very counterintuitive to make the legs do what they need to do in order to move. But if this is matched up properly with the actual movement speed, it will look like the foot stays planted and the rest of the body moves instead, relatively. Either way, we want to move this one a little bit forward now, and here we again get kind of back into the whole idea that we have fairly stubby legs, so some of this is a little bit tricky compared to what a normal human would be like. But we move our arms also back into their more neutral positions now, where they're kind of just balanced around the center of the body. And we go into pose number 4, the up pose. This is where we go even a little bit more up. This leg going back a little bit more and starting to go up and tilt a little bit, while the toe starts to kind of tiptoe a bit. And this is where we get into, if I just animate this toe going like this now, you will see that this toe actually ends up rotating over the entire course of the start of the animation to this pose. We don't want that. So we want to copy our starting pose keyframe for specifically this leg and just paste it in here. That way this toe only rotates through the duration of this segment of animation. This is also planted way too far down, I realize now. And that kind of thing can really come into haunt you when you have rotation and position keyframes on a certain thing, because it looks like, hey, we already have a handful of keyframes just going through here, but we might not. This is only position keyframes and not rotation keyframes. So keyframing this rotation is going to make it interpolate from the start to the end instead of from this keyframe to this keyframe. So I actually am going to, just for the ease of animating this, I'm going to just make a full like stack of keyframes for every single pose that we're doing here. That's going to help us prevent any like weirdness with interpolation that we're not expecting. Move this up a little, move it back a little bit more, rotate it down, and rotate this back so that this is now our point of contact. We only need this to be slightly lifted and slightly rotated, not majorly yet, but that'll kind of get us into a good position. This is now a leg that's going to be reaching forward, and where it was almost pointed entirely down in this position, ideally, so maybe it even should be pointing a bit more down than it is. In this position, it should start kind of reaching out because it's going to start planting itself down fairly soon. Then we can go into pose for frame 60, and this is going to be our contact pose, which means that we contact with the heel first. We can move these hips over a little bit. They go a fair bit down, and then this foot is properly starting to actually lift up, rotate down even more, maybe even a bit more back, and these toes are really only tiptoeing on the ground at this point. And with that, we can see we have what is essentially a single step. The last thing we need to do, by the way, which I almost did not do, is finish up the arc of the swing arm thingies. Talking about animating is not my best skill, as you can tell, but that will help a lot. Oh, this also didn't have any arm poses. So here we get into the other side of me just spamming keyframes everywhere, and that is that sometimes that kind of messes you up. The arms are going to be a little stiff, most likely here, but, well, it's not that bad. It's pretty decent. Again, the timing is terrible at the moment, but we'll look back at the timing in a moment. And we just do that entire cycle again, but with the other side. So now we go from contact to planting down with the green foot, and then we go all the way back until we arrive at where we started at pose frame number 0. I'm just going to do that super quickly, and we'll move on from there. And the next frame will be contact that we had right here. So we can just go back in and take this one, paste it at frame 120 or 119. Let's go for 120, and then see if everything loops the way that we would expect it to. It's not going to look great yet because we're taking 120 frames, which is 4 seconds to set 2 steps. So it's going to be a little slow-mo, but it is looping, and I don't think anything is jumping from place to place. It's a little bit of a pause, but again, it's just taking a moment to reset the playhead. If we export this, it should be a little bit more smooth. Now comes the timing bit, because we've just spaced these out 15 frames apart, every single one of them, and obviously that's not great. So we could start off by just speeding this up to being twice as fast and see how that looks, and that is already a good bit better. But we might want to start kind of moving some of these poses around in a way that adds a bit more energy to it. Like this pose over here. It's a little bit annoying, by the way. If you scale down animations, some of the keyframes can start being in between different frames, which is why I generally do like to just animate at a timeline that is as high frame rate as possible to prevent that from happening. So we're going to go over to 240 FPS now. But this little movement over here, just the contact to planting down at the foot, shouldn't take just as long as it does to lift an entire leg, should it? So we can select everything we have here and move this from 60 frames to being at frame number 30. So make it twice as fast. Let's actually go back to 120 frames because that is generally the speed that I'm used to judging these kind of things. And now this goes a lot faster, and it means that he's really planting down his foot. He's really stepping down, and that helps. Now this bit taking about 30 frames is honestly fine. I think this bit taking about that long is also fine. And then here again we have the blend down. So let's make that blend down once again. Just last 15 frames. So from 105 to 120. And just by moving those 2 little keyframes, it's making our walk animation just a lot smoother as it is. It's just this resetting of our loop that feels a little bit off. If you just go from the very end to the very start, we can see that there actually isn't any weird snapping. It might be that the arms are moving a little bit more quickly during these bits as well, so we might want to make the arms just move a little bit less extreme in these particular areas. So let's just move this a little bit back, move this one a little bit back, and that's already just a fair bit better. You can see his spine is super stiff though during this entire thing. And this is where you can start adding in keyframes to just this animation. Just going to this keyframe, adjusting the pose a little bit, and that can work, that can be fine. But what we can also do is we can just add a new animation layer. This adds a new layer that just adds on top of everything that we already have going on here. But we do want to kind of select the controls that we're going to be making a new layer for here, and then pressing the new layer. So that way it will make a new animation layer with all of those controls. And now we can say, well, we want to go back to frame number 0 of the animation as a whole and animate the whole animation layer 1. And we can rename this to something like spine and start adding on extra animation on top here. So we can kind of make just the spine lean forward a little bit as we take our step here. And then it can correct itself back to being a little bit more straight up as we get into the up position. Then while we're in the up position, it kind of stays the way it is. And then as we start going down again, so let's make a full keyframe here. So start going down again, it starts maybe leaning a little bit more forward. And that's going to give him a bit more life to just kind of moving as he walks. You also likely are going to want to give him a bit of hip tilt and a bit of shoulder tilt as he walks. And as he steps down, we even make him go down a little bit more. And his head is going to keep looking at this. We'll make a separate layer for that in a moment. But then he goes back up. So let's just copy and paste this over. And we'll start with our base pose at frame 0 also being slightly leaning forward. So we can make that happen like this. And now he's leaning a little bit more into his steps. Again, his head is still very stiff. But the wonderful thing is, now we could adjust the timing of these keyframes without having to worry about these. So we can kind of make the spine lag behind our movement or lean into our movement without this becoming a mess of just a bunch of keyframes which are going to be hard to read and just hard to keep track of. Now I'm going to add in a little bit of hip tilt as well. So as he is stepping forward with this foot, I want the hip to be a little bit tilted into this direction. And then the chest to be a little bit tilted in the opposite direction. And I was at frame 1 here and not at frame 0, so we kind of messed up there. We can just drag and drop these onto frame 0 to get those into position where we want them to be. And as we go back into our neutral pose, we can say, well, now this is okay to kind of go back into neutral here as well. And then at this point, we have it tilt in the opposite directions. And then just copy our starting pose again to here. And now his hips also move and his chest kind of rotates a little bit. And it's subtle, but it adds a bit more movement to his whole body. With that, let's make one more layer specifically for the head. So we just add a new layer, call that head aim. And that's going to make us a little bit less stiff in that regard as well. Because we want him to probably look a little bit more down. And then as he steps down, maybe he looks a little bit more up. The head movement probably should be relatively subtle. He leans back a little bit, so maybe make him look down. So that way it feels like he's keeping his head on the same spots. But as your body is moving, to keep focus on the same spots, your head actually needs to move to balance for your body's movement, right? So to keep focus on whatever he is walking toward, his head is going to need to do a bit of movement. So just adding a couple of keyframes of him having his head move a little bit more as he walks also helps a little bit, giving him personality. So he's definitely stepping down relatively strongly for just a normal walk cycle, but we've got him somewhat walking forward. And we're using 3 different layers to add on extra stuff where the timing, especially of this head layer, doesn't really line up with any of the keyframes in the 2 layers above it. And it just keeps things organized and neat and easier to adjust in the future. We've walked through the basics of setting up these animations now. I think that's going to be all that we need to do. So I'm going to create a linked animation sequence for this as well. I'm going to put that into animation sequences to character basic walk and save it. And now we'll have a walk cycle here as well, which now that we don't have the little stutter, you can see how it actually loops, and it loops a little bit better. It still has a bit of the jumpiness in that first step, but this is going to be more or less what we work with for our walk cycle. You also can add a run cycle. Just take your basic walk cycle, so level sequence, make sure everything is properly saved. We can duplicate this and call this run. If you do that, the reason that I'm showing this is because there is a little bit of a gotcha to it. We've just copied over a level sequence that has a linked animation sequence. So if we open this up now and we start adjusting this, we're still going to be overriding our walk animation because this level sequence knows that, hey, I'm linked to that animation sequence. So if you do that, you really want to go in here first and create a new linked animation sequence that kind of separates it from our walk animation. So we'll call this run character basic. I don't know, this is really bad naming as I'm doing it. But now this is separated into its own animation sequence, and you can start adjusting this stuff into its own poses. So because this is running, maybe what we want to do is tilt the spine a lot more forward, lean it forward a little bit more, and then also we can have this foot a lot more forward. Just like the reference I showed you before for the walk cycle, there's just people who have drawn the poses for a run cycle, and they're actually a little bit different from what I'm showing you here. So follow those as a guide more so than what I'm doing, but I'm just showing you how I'm working with these a little bit at the moment. Hopefully between the last episode and this one, you have done some animations and you've made something like a run animation. Again, what you're seeing here isn't fantastic, it's not perfect, but for the purposes of what we're doing here, it doesn't need to be. I've made a run animation, a very bad basic jump animation, as you can see right here. I've made a falling loop, because as we're in midair, we need something to just have a little bit of motion while we're falling. Apparently, I've saved that as two separate animations. And then I've made a basic dash that we're going to be working with here. So let's get started with that. We're going to go into our character blueprint. So in my tutorial folder, I have player and I have BP player character. We're going to finally replace the many that we have in here. I'm also going to get rid of that debug key. So go into the mesh and we're going to choose our own skeletal mesh there instead. It's going to be a bit smaller than the many. So we're going to go change the height of our capsule by a bit, and then we need to adjust our character mesh a little so that it's still inside, and that looks pretty decent. But right now he's just in T-pose. If we play the game, we are now our character, so that's fantastic. We can jump and we can do everything, but this is maybe not quite what we're looking for, right? We want him to animate. So he needs an animation blueprint, and he can't use the animation blueprint from Manny because his skeleton doesn't support that. We can just right click on our character again. We can create a animation blueprint for him. You can just stick with the default name, drag it over, and now it will be, well, I misclicked drag, that's really embarrassing, but still with it selected in the content browser, we can use this arrow to just set this as the animation blueprint. Opening that up, we are greeted with an entirely empty animation blueprint and all the animations that are supported by this skeleton for us to drag into it. So let's get started by dragging in our idle animation. We want to set this to being a looping animation because of course our idle should loop, and if we just drag it into the output pose here, we are idling. It's really as easy as that, but we want to go from idle to walking to running, depending on how fast we are moving. And for that, we're going to need a blend space. Coming back into our skeletal mesh, just right click, create. We can create a blend space. In this case, one dimensional is good enough because we only need to give him one value, which will be our walking speed. You can make a blend space 2D. that takes in two values. We've looked at that before, I believe. And if you have a character that needs to be able to walk left and right and forward and backward at different speeds, that's where a blend space with 2 dimensions becomes really, really cool. We only need a blend space 1D, and we'll call this idle walk run, and maybe BS for blend space. It means blend space, okay? And then also label it as being for the character. Opening that up, we get a view that is very similar to a normal animation view, but we've got this little graph down here. We can drag in our idle animation at a value of 0. Then we can drag in our walking animation, and that's going to exist somewhere fairly close to that at a value of, let's say, just 10. That means that if we walk at all, even just a little bit, we're going to very quickly interpolate from our standing still to our walking. And honestly, maybe we can pull those up to like 200, because the interpolation kind of works fairly well for a sneaking type of walk. A lot better than I thought it would. Of course, if you have a sneaking mechanic in your game, it probably is good to put in a sneaking animation in between here. But now we have set this thing to being up to a value of 100, and we want to add more to it. So we can come up in the asset details, and there, the horizontal axis, we can say the maximum value, let's set that to 1,000 instead. And there we drag in our running animation, which is this one. And we can set this one to work if we are at 1,000 speed. And then anything in between is going to interpolate between standing still to walking, and then walking even to running. So we can be halfway running, kind of like this jogging animation, and it works remarkably well, as you can see. If we're full on running, we'll just be running. So we've got that as a blend space now. Fantastic. Back in our animation blueprint, get rid of the single, just idle animation, drag in our walking to running blend space instead. This one should automatically be set to looping, so that's good. And we're still just idling, because we need to give in a value for how quickly we're moving. And that we do through the event graph. We talked a little bit about this before, but we've got this get pawn owner, and that's going to be the actor or the pawn that this animation blueprint is running on. We specifically know that this is going to be running on a character, and we don't need anything specifically from our BP player character, at least not at the moment. In the future we might. So it is good to cast this to just the base character class, because we don't need anything more specific than that. What we need from this is the get character movement component, which is somewhere down here, character movement, and we get the velocity from that. And we don't really care about the up and down velocity for this at the moment, but we might as well just promote this thing as a whole to a variable. That's fine. And then we can start using that to drive some stuff. So in the animation graph, we can use that velocity. Here, we don't care about the Z though, because we don't care about moving up or down. We just care how much we're moving along the ground. So we can transform this into a vector 2D, and that just gets rid of the Z component, which helps a lot. And then we get the length of that vector 2D, which is essentially an easy way to just get the speed at which we're moving. With that, we should now have a character that will be able to walk and run just like this. Now, the animations are a little scuffed, and we probably do want to just see how fast we're moving. If we go into the character movement component, we can say the max walk speed is 600. And 600 is probably pretty decent, but we are going to need to adjust the playback speeds of these animations to more or less feel like they fit with the speed at which we're running. So at 600, we are moving like this. At 1,000, we'd be moving like this. So let's maybe pull this down to 700 instead. And that's going to maybe feel a little bit better as we walk around here. Maybe we just want this to be 600, honestly. Maybe we just want to go full on into the running animation. But the animations are a little bad. The knee also is super glitchy. As I said before, we don't necessarily have the best animations here. I'm going to set this one to 750. If you have a controller that you're working with, you might want to see, hey, if I gradually go from walking very slowly to very quickly, how does it interpolate between these animations? Because there, the walking animation will actually be used. I'm using WASD, so clearly I only have either no walking or full-on running. But we're gonna stick with this. This works, even if it looks a little bad. And when I say a little bad, I mean a lot bad. We want to add in jumping and falling as well. And here we start going into maybe wanting to make a state machine for this. So what we can do is we can make a state machine, and we'll call this loco for locomotion. I'm just going to copy all this out, and the state machine is going to go into our outpost instead. If we double click the state machine, we can open it up. We have an entry, and then we can start making states. So let's make a state. This will be walking, and in there we just paste the entire thing that we just had, and that now works as a single state within the state machine. From entry, we always go to walking, and now we just reconstruct what we did before in the different animation blueprints, which has been a while, so it's good to refresh you on how all that works. We want to have one jump animation, and we want to have a falling animation. If you have a separate double jump animation, you drag that in as well. It is good to have double jumping be a separate state. If you will recall, the animation blueprint that we made for our player does also have a state machine, and we had a separate double jump state even though it was the same animation. And this is pretty much what we're going to replicate in here. So walking can go into jumping. Of course, jumping doesn't need to be able to go back into walking, because jumping goes into falling, and falling goes into walking. Walking also needs to be able to go straight into falling, and then falling and the double jump back into falling states need to be connected as well. And that's the whole flow that we had set up here. Let's set up these transitions just in the direction of this flow as well. Walking to jumping. We want to start playing the jumping animation when we are no longer on the ground and we know that we're moving upwards. We've done this in the previous animation blueprint as well. And the character itself has a very nice is falling. Well, it's actually in the character movement component. So we can just use that little thing over here. It has an is falling variable on it. So we can just promote this to a variable, name that is falling. And now we have a value that we can use for falling. So trying to go from walking to jumping, if we just double click this, we can script out a transition. We want to check, hey, are we falling and Boolean? So we want to check two things. Only if we're falling, and our velocity, break that vector, because we only care about the z, is greater than, let's say, 10, to make sure that we're actually for sure going up. Then we can do this transition into our jumping animation. Going back into the state machine, that's done. Jumping to falling just needs to happen when this character jump animation is done. And that's easily done by just saying, hey, this transition, I want to automatically rule based on sequence player state. When that finishes the sequence player, it's just going to transition from this into this. Then going from character falling into our double jump, we just do the same thing. We check, hey, are we falling and are we moving upward? That will trigger us to do a double jump. If we, for any other reason now, do get sent up, that would also make us play this animation. So there is something to the idea of maybe making the double jump a animation montage instead. Or maybe having a bool on your character that goes to true when you double jump and then goes back to false after like half a second or something like that. We're just going to copy over this code for now, because it is the most simple and straightforward way of doing it, and we can always tweak this later. Then going from our character jump back to our falling loop, of course, that also just whenever our character jump finishes. That leaves us with going from falling to walking and walking to falling, and that is super easy as well. Walking to falling just needs to happen when we are falling and our z velocity is less than 0, because that means that we're falling down and we're not going upward. And then from falling to walking, we just check, hey, our is falling, we do a not Boolean. Because whatever the case, if we are within our falling loop state, the only reason that we ever enter that is because our falling has been set to true at some point. So while in that state, we're just constantly going to be checking, hey, are we not falling now? Which means that have we landed back on the ground? And if that ends up being true, we just go back to our normal walking state. This is the basic state machine for our locomotion, and you'll see now we actually have my very bad jumping animation, which has a little bit of stuff left over at the end of it, because I didn't make this animation as short as it should be. The jump animation is really quite bad, but there we go. It does work, and it probably could do with just being faster and just being a better animation and all that stuff, but we have an animation that plays when we jump, so technically that works, it just looks bad. And when we fall off this, it will play the falling loop animation as well, and that's that. Which leaves us with only doing the dash. And the dash is something that I wanted to focus on a little bit for this video, because we're going to go back into our animation graph and we're going to add a default slot. This is an animation slot, again, something that we've done before in the animation graph for this one as well. And this allows us to play animation montages, which, at least for the default slot, just overrides the entire animation that goes into it with an animation montage while it is playing. And then when the animation montage finishes playing, it just interpolates back to whatever the input was doing. Before we do that, however, we need to make sure that our animation for dash is set to using root motion. If we go into my level sequences, into the dash level sequence, just to show you, I used this white controller that we made for the player root, and I animated that forward with the dash animation like this. This is now capable of being used as root motion, but by default it will not actually do that. By default it will just act as a normal bone in a normal animation, and by the end of the animation your character is going to be jumping back to its origin point. I will show you that right now. If I go in and do our character dash, it just jumps back to its origin point over and over and over again. You can see it's not root motion because it doesn't have a motion trail down here at its feet. If we go ahead and we look for root motion, we can enable root motion on this animation sequence, and now it has that motion trail. It also kind of shoots off into the distance because it tries to normalize the root motion scale. It kind of freaks out with that sometimes, so you can just turn this off, and now it does what you'd expect it to do. You can see the motion trail, and we know that this is now root motion. However, this still is a animation sequence, and we need to play this as an animation montage. So we just right click it, create, and a montage, and now we can use it as a montage, as easily as that. The montage itself has no root motion settings. You need to set up the root motion settings in the animation sequence, and then the montage is just kind of a container for that can be played on a animation slot in our animation blueprint. So somewhere in here, I have some code that plays a montage when I dash. So let's try and find that. It's right over here, play montage. And that is right now just playing the air dash animation that we have from our mannequin. But we're going to be replacing that with the animation montage that we ourselves made. And now we also have the dash. There seems to be a little bit of a bugginess caused where it kind of creates an issue where there's no gravity anymore. So let me try to figure out why that might be. It seems like maybe it's at no point starting this gravity scaling anymore, which would be weird, but we just added in a print string to see, yeah, it does not do that anymore. You see, we had that as an animation notify that we made in the animation montage itself that would call our end dash. So we need to end dash from our animation montage as well. So let's do that. By the end of this, we are done dashing. So here we just put in notify. These are the type of things that you just do forget after a month of not looking at this stuff. So that should fix that. We have our dash. It's a little bit of a clunky dash in some ways, just as the jump is clunky, but all in all, we have all of the animations that we did before, but now with our own little character, and we can start adjusting these as we see fit. All this started with the idea that we want a character model for our enemy, though, so that we can give him a attacking animation, and we can, well, number one, start dodging that attack, because right now he will always hit the attack when he just gets close to us. And number two, also just have him look less goofy than he is right now. And with the way we've got everything set up over the last handful of videos, right now, it's really easy to reuse the animations we've made on a new model. Because if we just import a new model that uses the same skeleton, we can reuse all the walking and running animations that we've made so far. And we can just add in one simple punching animation, and we've got our enemy ready to go. So that's what we're going to be focusing on next time. I'm going to make a quick variation of our base mesh that's going to function as a fun little enemy for us to fight. And the next time we're going to import that and show you how easily we can expand from this point now. I promised you a new character, and here we have it. Did I spend a lot of time making him? No. But the point here being is that it's really quick and easy to change existing geometry. I extruded this out from the head as a separate little mesh that is still part of this skeleton, and then just drew on some new, very low quality textures. And the important thing that you need to take a look at is that I have these two bits of mesh, and they're parented to the same armature as I did for the player. I made a separate one for the player in the video where I made the player to showcase that you can make separate armatures just with the same hierarchy. The tiny issue with that is that Blender doesn't allow you to name two of the armatures the same thing, but Unreal wants the armatures to have the same name. So if I export this under a different armature with a different name, Unreal is going to be unable to merge those armatures together properly, and that's just a bit of a bother. And if you want to separate all the meshes for your different characters, the best way to do that would be to just make some collections. So we can make a new collection, and we'll make a collection for our goblin dude. Then these meshes can exist within that collection, so they're still separated from all of our player stuff, but they all belong to the same skeleton here. Once we've done that, we select all of our meshes, we select the one skeleton that we have. We don't have multiple skeletons, ignore the base one that we have here, we're not going to be using it anymore. And we just go export FBX as usual. Make sure we're only exporting the selected objects. I named this goblin.fbx because why not? And then we can just, in our enemy folder in Unreal, let's make a assets subfolder for this and drag in the goblin. Now don't just spam through this import window this time. We're going to scroll down a little bit, and here we can assign this mesh that we're trying to import to an existing skeleton. So we're going to map it to the character's skeleton. If you did import this with a different skeleton from a different armature in Blender, it's likely going to give you a warning here saying that it can't merge them together. And sometimes Unreal can just kind of figure it out, but sometimes it has some issues and it becomes a little annoying to deal with. So this is just a smoother way to do it. I can now import this, and it imports the skeletal mesh. It makes a new physics asset. It even makes the material to go along with it. I will need to also go in and export the texture that I'm using for this. So let's drag that into the engine as well, so that we have that in here. It's probably can just go into this material instance somewhere. Texture parameter, that'll be the diffuse color map. Diffuse is just a word for the base colors that shaders use, and that'll be the goblin textures. And then in the global scalar parameters, we apparently need to set the diffuse color map weight to 1 because this material is just weird. But now he looks like he did in Blender. We can go back into the LODs as well, not recompute normals to have everything still be blocky because that's the way that I like it for this project. And you will see that it didn't make a new skeleton, because if we go to the skeleton that we're using here, it'll just take us to our original skeleton for our player. And that, in very short, means opening up this BP enemy. We can straight up just put in the skeleton mesh for our enemy here. That's fine. We'll need to adjust some of the colliders. This capsule needs to be a little bit smaller. This sphere collider might need to be a little bit lower down. Aside from that, it's pretty much good. And for right now, we can just make it run off the same animation blueprint as we had for the player, which I forgot the name of. So let me real quick go find that one. This one right here. It uses the same animations. Everything is the exact same. It's using a different model. It's not just a different texture on this model. It straight up is a different model. He's got a little hat. He doesn't have the belt. He doesn't have the hair. And if we look at this, we can see he runs back and forth. He used the exact same animations that we did. He runs up to us and he is able to hit us in the face. He also is blocking my camera view, and that is because probably the mesh is set to character mesh, which will block the camera. That's a little annoying. So if we set this to just ignore the camera with a custom collision preset, the camera will no longer do that weird thing. So now he can walk up and hit us in the face. At this point, we can just make a hitting animation and make him play that when we are supposed to be getting hit. And the wonderful thing is, if at any point our player character needs a hitting animation, we can just reuse that same animation. We can just animate on this, just copy over one of these level sequences again from character idle, let's say, ls, character punch, immediately make a linked animation sequence as well, because otherwise we're going to accidentally be overriding stuff that we don't want to override. So animation sequence, character punch, and we'll just take about 20 frames time for him to, I don't know, rotate his hips back a little to wind up for the punch. Also maybe make him look away ever so slightly. It might be nice to parent this control to the neck control, by the way, so we still have a way to like rotate the head around, because right now it's not doing that. Not super important. We can just manually move this thing around a little. Move the hand up and back so that he's really winding up that punch. It's not the best animation, I will admit, as are all the animations, because everything that we're making here I'm making pretty quickly, and I'm not a great animator at the best of times, so take that as you will. And then give him like 10 frames to... First, let's just go back to the basic pose that we had, and then make him kind of rotate through one spine segment at a time. Definitely also want him to be leaning forward if he's punching. That kind of makes sense, right? And this is where the head aiming kind of starts to fall apart. So you might even want to make separate control rigs for separate animations that focus on, well, for this one I want him to look at a point, and for another one I might want to be just rotating a spine segment like I do for the, well, rest of the spine control he had. You can make one control rig that just switches between those, but that becomes extra complicated, and if one animation only requires one thing or the other, it might just be easier to make multiple control rigs for that type of stuff. That said, his neck is definitely snapping right about now, so let's something like that. And then just take another 15 frames to reset back to his base pose. And then we have a very, very bad punching animation, but it is a punching animation that we can now do stuff with. And that means that finally we can go back into this guy's behavior tree, or state tree rather, and his attack right now is just damage targets. That's not that much. That's not that great. So let's go back into that state tree task and apply damage a little bit differently. What we'll do is we will play a montage, and we'll play a montage on the skeletal mesh component of our context actor. This context actor is just a actor class, so it doesn't have an easy reference to a character mesh. So we'll change this to a character type object reference. And that is entirely fine because we know that our context is a BP base enemy type reference, which is a child of the character class. So it is already a more specific type than the character. We very much could make this just BP base enemy, but again, good practice to only make any type of variable, any type of reference as specific as it needs to be at any given time. So then we get the mesh, which is just a thing that we can do when we have a character reference, put that into the skeletal mesh component here. And then the montage we want to play is a variable. So we'll say montage to play, and we'll expose that so that we can change that on a per task basis. All the code is going to remain the same between different enemies, between different attacks. It's just going to be playing an animation, and it's going to be waiting for a certain time in that animation to check if we can hit the player or not. So instead of going directly from play montage into apply damage, we will check on notify begin. And we're going to be making sure that we do the right notify, because it's going to send through the name of the notify that we're going to be working with here. So when we receive a notification, we want to check, hey, is that notification equal to Let's call this impact. If it isn't, we might be sending through a different notification for different purposes, so we don't want to do anything here. But if it is equal to our impact, what we will do is we will sphere overlap actors, and we're going to check at a certain position within a certain radius, are we near the player or is the player within this sphere? And if so, we're going to damage him. The sphere position we can get from the socket or the bone in our skeleton. Our skeleton, of course, being made up of bones. We can get the specific location of any of these bones within the world. And as we already have a reference to the mesh, we can just get socket location, and that gets you the world location of any given socket. You can make sockets on meshes as well, which are kind of like semi-bones. They're not really bones, but they can be attached to a bone and be used for things like attaching other objects to or getting specific relative positions to a bone, which can be quite useful. We're just going to stick with using a bone for now, though. And this is also going to be a variable, and we will call that the impact sockets. That's what we're going to be impacting. We'll make a radius, also a variable, impact radius. Set that to a default of, I don't know, like 50. Seems pretty good. And then we need to make sure that we're giving in the right object types. You need to make an array for this, and there you can give in all the collision types that this needs to respond to. In this case, we're only really checking if we're overlapping with the player in this sphere, so that'll be of type pawn, because our player is a pawn type in its collision settings. That's going to output an array of actors that are within this actor filter class, if we want to set it up, that aren't the actors that we want to ignore. We can give in specific actors to ignore and fall within this object type of collision. What we're just going to do is we're going to for each loop over that, and that's going to take this array and just go over every single entry in this array one at a time. So every time this loop body runs, we get an array element as a reference to just the next thing down the list. And in this case, we just want to check, hey, is this thing that we're checking right now, is this the get player pawn? If it isn't, we don't really want to do anything. We could try to apply damage to things that aren't the player, but we don't really care about that. So only if it is the player. We could also just use the target reference. I forgot that we have that, but sure. If whatever we are checking in this for each loop is the player, then we apply damage and immediately finish the task because we don't really need to do anything else. So let's compile that and go back into our state tree. Now we have this montage to play and this base damage, and our in actor is no longer valid, and I wonder why that might be. Oh, we made the wrong thing into a different type of reference. The target still needs to be an actor. It's the context that I needed to be a character. Wasn't paying attention there. That is my bad. So let's get the mesh from our actor, not from our target. Anything else is messed up here? I don't think so. And yeah, that fixes that. So the target is actor.target. Base damage, we'll just call that 1. The montage to play will be our punching animation, but we don't have a montage for that yet. So let's go back into where I have my animations. And in here somewhere now I have a punch, right? Yes, I do. I can just create an animation montage of that, and now it'll function as a montage. Show up in this list as well, punch montage. The socket that we're going to be working from here, we can check which hand we use because I don't remember. It is this hand that we want to be working off of, so we can just go into the skeleton tree and figure out which hand that is. It is the left hand, and that's immediately a pretty good one to use. So in a tree view like this for the skeleton, you can just right-click any given bone or socket. We can add sockets to it, and as you can see, that just adds in a little thing which will be relative to whatever bone it is attached to. Really quite nice. Not really the point that we're going for right now. What I'm going for right now is you can just copy a specific bone's name. And since we're going to be getting this based on a name, it's nice to just be able to copy and paste it. Don't try to type this. You're going to make typos and things are going to break. Whenever you can copy paste names, copy and paste them. Clicking over back and forth between 2 tabs is much less trouble than trying to spend 10 minutes figuring out an issue and finding out it was a typo. And then in the animation, we still need to add in that notify. So we can just add in a notify, and there is this montage notify that just exists in Engine by default. I can just send out a notify with a name. So if we give this notify the name, I think I called it impact. Once again, just do make sure that if you do anything like this, you copy and paste your stuff around, because if you make a typo, you're going to be like, it doesn't work. You made a typo. That's why it doesn't work. And now our guy is going to try to punch us, and will only actually get damaged after the punching animation finishes. And if we moved out of the way in the meantime, we didn't get damaged. However, there's one issue, and that is if we run out of the way, it never gets to player pawn equals whatever we're checking in the for each loop. So it never applies damage, so it never finishes the task. We also need to finish the task if the whole for each loop runs all the way through. Then this completed runs, so that's only once everything in the array has been checked. And then we can run finish task as well. And that means we now have a dodgeable attack and an enemy that is starting to feel like it actually is a NPC. It's a proper little enemy that we can fight against and we can jump on, and we got a game. So now that we have a game, it is time to start polishing this up. Am I going to polish up the assets that I made? Unlikely. But we do want to add a little bit of juice to this, which is to say we want to add in some more fancy materials, maybe. We want to add in some particles, maybe some camera shake, definitely some sound. And that's going to start making the whole game just come together a little bit more. Now that we have these little goblins, we can go back into our tutorial level, even if we wanted to. So the tutorial level, save everything that we have in here, that's fine. And just put down a couple of these little guys. So in this area over here, just put down, I don't know, 2 of these enemies. That seems pretty good. And then both give them some target points that they can walk between. So this will walk from here to there to there. And then this one will maybe like just walk in a bit of a triangle formation between these. Can go into each one of these, into the state tree. Their points array. They're both going to have 3 points. This one is going to walk from this to this to this. They very much could share points as well. It's not like once one of these has claimed a point as a point of interest that they walk between, the other one can't do that. They might just at some point start walking to the same point at the same time. That looks a little goofy, but you could make it do that. That's not going to be a problem at all. And just like that, we now have our enemies in our actual area here. And now that these models exist within the context of all the other low quality and low poly models, it is starting to look a little bit less ridiculous, right? This feels like it fits a little bit more. The animations still are pretty bad, don't get me wrong, but we've got a thing going on here. This guy, however, is infinitely punching, and that is because I forgot something that you're going to be forgetting a lot of the time as well. I didn't give these guys a nav mesh, so they can't walk around. Just make the nav mesh big enough for this entire section over here so that they have freedom of navigation. And now they can walk around so they won't get stuck in the punching state infinitely. At least in theory. Let's check out if that is true. Yeah, you see, they are patrolling and now they can both see me, so they're both going to come after me. The moment they can't reach me anymore, they should go back to their patrolling states. Just like that. That'll be section 2 of this insanely long series where we focused on character creation. As I said a moment ago, the next bit is going to be focusing in a little bit more on adding polish and juice, as we like to call it, which is just to say player feedback. And that comes with a lot of visual stuff. Largely going to be all in Engine though. We're done with Blender related stuff for a little while. I might come back and make a boss fight to finish off the entire series at the very end. And we probably will go back to Blender for making a character model for that specific. But for now, this has been section 2 of making your first game, the character adventure, let's call it. And I will be back soon enough with the start of section number 3. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. With a special thanks to my Cave student tier supporters Oiku and Earl Monseville Erno. And I gave Digger tier supporters Mauricio Farias, Cheng the Dude, and Joshimator.